Another day, another memo. Would you look at that? It's paper 2. Okay, that was it was okay. It was an okay intro. Anyways, so obviously we are here to work out paper 2 of the June the 2021 June supplementary math exam paper 2 memo. That's what we are going through. So anyways, without wasting any time, obviously we have some stats. This empty PDF file is about to be not so empty. So here we are go. So as you can see here, the first question here is asking us to do what? Well, obviously we need to read the description first. And it says, Sam, such a blunt name, guys. Y'all could have thought of something, some creative, Isn't this like an essay paper? Should have put like a lirato here or something, on a lady. We're tired of Sams, guys. Okay, we're not, but I'm just putting it out there, should have seen here. Katleho recorded the amount of data in MB, in megabytes. Oh, we're talking about data now. Okay. Yeah, Sam recorded the amount of data. Oh, data. I mean, this is stats. When we hear data, we think, oh, data. No, data. I think data is like, phone data. Data is like, yeah, let's just carry on. So, yeah, this person recorded the amount of data that she had used on each of the first 15 days in April. The amount of data used on each of the first days in April. Then the information is shown in the table below. What year is this? Is this 2004? How? 16 megabytes in a day. Liar, you're lying. I don't know whose data this is, but this person, let's see. Well, they didn't say Sam is in school or whatever. Maybe Sam is an old man, huh? Doesn't use his phone much because this is so unrealistic, like goodness. Anyways, fine. This is the data used on each of the first 15 days in April. Oh, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Oh, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so first 15 days, ne? This is what she used. She's very conservative. She's very conservative. Or he. Why do I keep saying she? Maybe it's because the only Sam I know is actually she. Just like Max. The only Max I know is a she. So that's quite interesting. Anyways, it says here calculate the mean for the data set. So, and then here they're going to ask us for the standard deviation eventually. And then here we're going to need to use the standard deviation and the mean. So for these questions here, you definitely need to throw in this data into your calculator. Now, what we're about to do here is something that we have showcased in the statistics course on our course platform. So, I mean, this is something that you've probably flew through if you wrote this paper or if you're like using it to like study. So in your calculator, you're going to need to press mode and then stat and then var. Let me actually write that down here. So here, you're going to need to, in your calculator, you're going to press these three in this order. You're going to click on mode and then you choose the stat option and then you choose var. You see, that's simple. So what's going to come out is like a column. There's a column or column, whatever it is, this comes out. It has an X at the top there. So in here is where you put in your data. Data. That's a pun. Your data. Because this is data. Okay, but I think you get it. If you didn't get it, wapora Joe, you're boring. I'm kidding. I'm kidding. So the first number is 26, going on and on. So you just put every value and you just press equal to afterwards. So let me just do that quickly. There we go, 40 pieces of data. Now, obviously, if you want to get your mean, this is what you do. So once you've put in all your data, right, you just press on. You see, you literally just press on. So let me actually put an arrow here. You just press on afterwards. After you press on, to get your mean here, you're going to need to press shift and then you're going to need to press number 1. The number 1 button has like a stat on top of it. So you press shift and then the number 1 button on your calculator, the recommended calculator for like high school learners. It's what is this calculator code? It's the FX82ZA. That one. I mean, you know it. If you don't know it, oh my goodness. But anyways, so you press shift and then stat, and then what you press shift stat, and then you press var and then 2. And then obviously when you do that in your calculator, it should give you the mean. So let's see what the mean is here. You press 2 equal to, and then it's like 25. Sam, please teach us how to. No. Keep your tactics. Nah, it's fine. I'll spend a gig a day. It's okay. But 25 gigs a day, 25 megabytes for you a day. Hey, you do you, man. You do you. We ain't gonna judge you, but we ain't gonna do what you do. Cause hey, some of us, yeah, we want to see the boys and stuff like that. So yeah, it's not gonna 25 megabytes is just not gonna cut it, because when those videos drop on Fridays, you know what it do. I'm chilling with the boys. 25 megabytes is not gonna cut it, okay? So I'm sorry. But anyways, standard deviation. Let's see here. Your standard deviation, you're gonna need to press shift stat var, and then let's just write it down here. The symbol that I'm referring to, shift stat and then var, it looks like a 6 with an X, but let me just try and write which number it will be. And then obviously in your calculator, if you press equal to over here, what you get, you're gonna get 17.65. So that's okay. So remember, in the course, right, we mentioned in the statistics course, we mentioned that your standard deviation gives you an idea of the it tells you on average how far each piece of data is away from the mean. You see, that's what standard deviation is, according to what we stated in the course, the statistics. Yeah, the what? Your goodness, bro, come on, the statistics course on the online course platform. The link to that is in the description. Whenever you're ready, you can check that out. Yeah, so you see, that's what standard deviation is. It is the average. It gives you an average of how far each piece of data is from the mean. We have got it over here, got 2 marks plus 1, so 3, that's okay. We keep going. 2 more marks. It says determine the number of days on which the amount of data used was greater than 1 standard deviation above the mean. So questions like these, they're not crazy. Just read nicely. Determine the number of days. Okay, so we need the number of days on which the amount of data used was greater than 1 standard deviation above the mean. So when they speak of something that's 1 standard deviation above the mean, or when they speak of a question like this, they're asking how many days we should determine the number of days of which the amount of data used was greater than 1 standard deviation from the mean. So these last few words here, in as much as they may seem a bit confusing, all you want to keep in mind is that anytime they ask you for cases like these here, they're talking about something being 1 standard deviation above the mean. So here, determine the number of days on which the amount of data used was greater. Okay, keyword here is greater than 1 standard deviation from the mean, or 1 standard deviation above the mean. So 1 standard deviation above the mean is literally standard deviation plus the mean ones. This is 1 standard deviation above the mean, which is just this value here. Obviously in our calculator, let's see what that is. In our calculator, and 1 standard deviation above the mean gives you, what does it give you? It gives you 42.65. Hey, what a wow. Yeah, this doesn't want to make sense, eh? Yeah, it really doesn't want to make sense. But we do have values here that are a bit weird, like your 3 here and your 69. Yeah, so the values like a 3 here and your 69, they are basically obviously contributing to the average with regards to how far values are from the mean. So that's something that we should not be too afraid of. So here they say determine the number of days on which the amount of data used was greater than 1 standard deviation above the mean. So we are looking for days where the amount of data used is bigger than 42.65. So those are not many. There's literally, I think, like 1 day that is 1 standard deviation above the mean. So let's check that out. There we go. Oh, 2. Ooh, okay. 1, 2. These are the only 2 days that are above 1 standard deviation from the mean. So technically, our answer here, we're just going to say 2 days. Okay, fantastic. Not so bad. 2 marks you get, and then you move on. 1.1.3, I'm going to have this question on the course as like a bonus question, just for this one here, because you see stuff like this is showcased. However, this is, I think, a good question. Calculate the maximum total amount. Okay, calculate the maximum. Oh, okay. This question, I feel like we need to read carefully, because look, it's out of 3. Secondly, yeah, they're talking about maximum stuff, and you know how these words can be in math sometimes. You know, it's like triggered. They said maximum. It's like instant trigger. Anyways, it says calculate the maximum total number of data, okay, that Sam must use for the remainder of the month. Okay, if she wishes for the overall mean of April to be 80% of the mean for the first 15 days. So questions like these, they require you to just analyze the question a bit. They say calculate the maximum total amount of data, right, that Sam must use, the maximum total amount of data that Sam must use for the remainder of the month if she wishes for the overall mean of April to be 80% of the mean for the first 15 days. So what I will do first is, let's work out what is 80% of the mean. 80% of the mean so far in our calculator, what is that, please? 80 shift percent times 25. What you get? You get a 20. So 80% of the mean currently would be 20. Okay, so here it says calculate the, you see, I keep reading it over and over again because I'm trying to get a better understanding as to what we should do. You see, don't just jump into questions. You see, you'll get hurt. You'll get hurt. You'll hurt yourself. So don't do that. So here, yeah, we should calculate the maximum total amount of data that Sam must use for the remainder of the month if she wishes for the overall mean of April to be 80% of the mean for the first 15 days. So a question like this, right, don't overthink it. Try and think softly, and well, it is a bit of an intricate question. So in my opinion, in an exam, this is one of the questions I would have left and came back to afterwards, like genuinely speaking. Even if I was writing this exam when it was written like a few days ago, I would have just looked at this question. I can understand it, yes, but because it's just for 3 marks, I understand also that the amount of time I would spend on this question is not like 3 minutes only. So it's best for me to tackle a question like this only after I've gone through everything, you see. But anyways, for the sake of this video, we kind of need to, we kind of need to do what? We kind of need to just dive into this question. So what I would do is, obviously you may be asking yourself, but then for the remainder of April, is it 30 days in total for the month or 31 days? That's a good question, man. That's a good question. So the best number to work with regards to like a month is just 30 days. You see, just stick to 30 days. You'll be safe. So in our case, if you think of it, right, let's look at this as like 1 month. Okay. So in this 1 month, you see, we're analyzing this thing. We're psychoanalyzing it because why not? Why not? I need to, they want us to give an answer. So we'll give you an answer, Baba. What you're trying to remember is that you see here, the first 15 days, we have here 15 days. What we want to recognize about these first 15 days is that our average / our mean is 25. So our task here, right, if we can break it down nicely, our task literally is saying that we should take this mean here, right, which is 25, and we should add it to a mean here that we don't know. Let's label this M. You see, we should take they're basically saying we should take this mean plus this average for the next 15 days. And then when we get the average for the entire month, our average should be 20. So let me repeat that nice and slow. Our question technically says we have used an average of 25 in the first 15 days. And we don't know what's the average for the next 15 days. However, if you take this average and this average here, and you get an average for the entire month, they have told us that we should get a mean value of 20, you see. So literally a question like this one, in as much as it may seem a bit funny or weird, it's actually quite simple, because luckily you can just say here, okay, fine, the 25 plus the m, right? If I put this together and I divide this by, well, technically we just want the average of these two to be a 20, you see. So these two added together, if you divide by 2, we want their average to be a 20, because we want the average between these two to be a 20, you see, because first 15 days, second 15 days, the average here should be a 20, you see, of which average is just adding these two up and dividing by 2. So here, if you multiply by 2 on both sides, let's see what you got here. You can multiply by 2 over here. Let's see. What am I trying to do here? What am I trying to do? I'm trying to multiply by 2. Multiply by 2 here. Excuse me, I'm trying to fix myself here. Because everything is getting tangled, like the mic and the this and the that. It's like, okay, I'm ready now. I'm ready. So this is times 2 on this side. It's times 2 on this side. And then obviously what you're gonna do is the 2 here is gonna cancel the 2 down there. And then you're gonna have 25 plus m is equal to 40. Move the 25 over, you got 40 minus 25. What you got? Hey, now I won't even lie to you, I'm reaching over for the calculator and I'm verifying this 15 here, because my mind is like 20, 50, 40 minus 25, that's 15, And then the other side of my mind was like, hey, 15, my guy. Let's double check. So yeah, the average for the next 15 days, right? Funny enough, has to be a 15. This is all a coincidence. Like, yo, don't let these numbers fool you, hey? This is just a coincidence that this number is a 15. Okay, so don't panic. So basically what we're saying here is, you see here they said, calculate the maximum total amount of data that Sam must use for the remainder of the month if she wishes for the overall mean of April to be 80% of the mean for the first 15 days. So here we're seeing that if the average here and the average here gives you a 20, it means that the average amount of data used for the next 15 days should actually just be 15 megabytes, of which we know that 15 megabytes is the average that she has to use for the entire 15 days. So the overall data that she's going to use for these 15 days is obviously 15 per day times 15 days. You see, because obviously if this is the average for the next 15 days, it means that each day she needs to use a maximum of 15 megabytes. So 15 megabytes per day gives us a total of how many megabytes can she use in total for her average to be 20. So the total amount of megabytes that she should use for the next 15 days is 225 megabytes. Here person is strong. 225 megabytes in 2 weeks. Yeah, see man, goodness, what you do with your phone, you just look at it. You must open it, man, go to Instagram or something, go like some pictures, you'll use more data. But anyways, let's not judge people and not using a lot of data, because I mean, who says you have to use a lot of data anyways? Like, what the hell, bro? Like, what the hell? Leave this person alone, okay? Maybe they actually, yeah, they're just different, they're just different, which is dope. It's dope. It's dope. So anyways, here let's just move on. So this question, you see, it was quite intricate, so obviously I would have just came back to it later. But anyways, yeah, let me actually put here per day, just so that on the memo it It shows, you see, it shows. Anyways, let's carry on. We ain't got no time to be wasting. 3 more marks. So what you want? It says with the wind speed in kilometers per hour and temperature in degrees Celsius for a certain town were recorded at 4 for a period of 10 days. Okay, the information is shown in the table below. Okay, wind speed in kilometers per hour. Okay, I don't know, this looks fast, and the rest is okay. And then here temperatures 28, 26, 22. Okay, these are not so bad. This is more like Joburg weather, Joburg weather in like autumn or something, because as I'm recording this, it's currently winter, and yo, it's cold, people. It's cold. Like, it's so cold. At least now I'm feeling warm, yana, warm hands, warm feet. But most of the time, cold feet, cold hands, and you're indoors and you're like, what is going on? Anyways, here it says determine the equation of the least squares regression line. Okay, yeah. So here we have two sets of data, right? Two sets of data. We have wind speed and temperature. So even before you look at whatever question they are asking here, if we try to see if this data is linked in some way, yeah, it's hard to tell, But anytime they ask for an equation of the least squares regression line, the big issue in a scenario like that is that you also just need to use your calculator. This data here, you need to put it into the calculator, okay? So in your calculator, this is how you put in this data. It's quite similar to what you did in the first question over there. So in your calculator, obviously you do want to clear your calculator first. You see, you definitely want to clear your calculator first, because yeah, it's just a good idea to do that. So here on top, let me just put here clear calculator. And yeah, writing in like caps is like is a tiny nightmare. I don't know how adults write in caps, because yeah, they know how to do that stuff. Clear calculator. I'm saying adults as well. I'm not an adult myself. Like, wow, bro, like, what the hell? Hey guys, now I'm not an adult yet, okay? I'm not an adult yet, I'm still growing up. When I grow up, I want to become a bank. Yeah, but anyways, let's see, 3 marks. They want the equation of the least squares regression line. So obviously, you're gonna clear your calculator. So to clear your calculator, this is what you are do. You're gonna press the shift. This you probably know, but just showcasing it net for control. You press shift and then you are press 9, and then what else? Let's actually be doing that, because I'm actually just saying it. Shift 9 and then all, of course. Shift 9 and then all, please, all. Danko, and then what now? Equal to, and then just yeah. I think from here you will literally be done, because I mean, like, yeah. So anyways, you've cleared your calculator. So I've just cleared mine now. So we are ready to output this information in the calculator. So anyways, putting this information in the calculator, this is what you do. You're gonna press shift. The lies. You're gonna press mode first. And then you're gonna press what? Stat. Yeah, there's gonna be a stat option there. Let me actually just put this here. And then let's actually be doing it before I read the wrong things here. Mode, and then you press stat, and then you press the second button, the one that has the A plus B stuff. You see, you press this one here, A plus BX. So all this is exactly what we go through in like the stats course, because you see, the stats course prepares you for the exams after you've gone through like the tutorials on the channel and you're ready to like practice. The course platform is like perfect for that. So anyways, the big issue here is that, what's the big issue? Well, it's not an issue actually. So once you do this, now you can put data into your calculator, because once you press this button, 2 columns are gonna pop out. One of them is gonna have an X at the top over there. One of them is gonna have a Y at the top over. Yeah. I think you get the idea. So the idea is that 99.99% of the time, you see, this on top here will be the X, and then the one at the bottom here, the bottom or Y, will be Y data there. So you put in the x ones first, you finish, and then you put the y ones afterwards, you finish. So you see, you put all these first in this column, and then you put all these after in this column. So let me do that quickly. Okay, so all the data is in the calculator now. Once you've put everything in the calculator, you can just press on, you know, because it's like you're ready. You are ready to do what? You're ready to get your marks for free, because you see here it's just giving you marks for doing what? For just putting in data. So yeah, let me actually just try and let me put this over there. Okay, yeah, this is to say this data goes in there. So your equation of the least squares regression line, once you've put in all your data, right, this is what you want to remember. Your equation of your least squares regression line just looks what you're doing, man, just right nicely, man. This is too okay, this looks fine. So your equation is just y is equal to a plus bx. This is also on your formula sheet. So for you to get a and b, it's simple. You just use your calculator. So in your calculator, you're gonna press these. Let's see, shift stat and then what? Shift stat and then what's coming up here? Oh, you press a reg afterwards. You see, because I'm looking at the calculator and the calculator reminded me. So you press shift stat and then you press 5 here for reg, and then you see there's a and b popping out there. Perfect. So obviously you go a first, and then eventually you can do b afterwards. There we go. So obviously these take turns, you know. You get a first, you do the same thing again, you get b. So getting a is just 1. You're gonna get over here 29.35. Yeah, rounding up to 2 decimal places is fine. 20 what? 29.335. Yeah. And then you do the same thing again. You see, shift stat and then reg and then 2 for b. You press equal to. Don't forget to press equal to, otherwise yeah, you won't be happy with yourself. But anyways, this is -0.46. so obviously this being done, you can then say therefore y is equal to 29 point this about to lie hard. 0.46. Perfect. And then you drop your x over there. The idea here is that this is free marks. You get them and you keep on running. Don't even look back. Just keep going. Predict the temperature at 4 if on a certain day the wind speed of this town was 9 kilometers per hour. So obviously, I mean, all these readings here, these are all at 4. You see, they're all at 4 by default. The thing here is they want us to predict. Anytime they want you to predict, as we have already showcased in like the statistics course, anytime they ask you to predict, all that means is you need to use your equation. You see, use your equation. Your equation here just looks like this. I don't know why I rewrote that. I could have literally copied it and pasted it, but no. It's fine. Anyways, so predicting here, they said on a certain day the wind speed is 9 kilometers per hour. So you see, that's why this is important for you to see what is going to be x, what is going to be y. So wind speed here is technically represented by x, you see. So if the wind speed is 9 kilometers per hour, you see this is a value for x. So if you're going to predict what the temperature will be, let's see here. Throw a 9 over there. What you got? Let us see here. There we go. 25.21. That sounds super believable because it's so close to the, like, you know, the amount, the kind of data we're dealing with. So here, this is 25.21. Obviously, this is like, you know, to 2 decimal places and stuff like that. However, if you look at, you see, our temperatures have whole numbers. So you might as well also, you know, just write this as an approximation. This is the approximation symbol. So your temperature is approximately 25 degrees Celsius or degrees Celsius, Why did I say degrees Celsius? Okay, never mind. Let's keep going, please. B is quite an interesting question, and the funny thing is, on the course, there is a question exactly like this. I kid you not. It says interpret the value of B in the context of the data. So what you want to think to yourself is, I mean, if you look at it, right? If you look at it, this here should almost remind you of like a straight line, one way or the other. You see? Yeah, one way or the other. So your value of B should remind you of gradient. You see? So here, if you're looking at this value here, we can already see that this here, you want to think of it in terms of, let's see, the X here, we said it is definitely dealing with like wind speed and stuff like that. So if they're saying interpret the value of B in the context of the data. So in the context of the data, right, this value of B here is literally telling us that the wind speed is somewhat expected to drop by 0.46 kilometers per hour. You see, because remember we said this is representing something like gradient. So because this is a negative number, we can already see that the gradient of this straight line would be like dropping. You see, so if the gradient of that straight line would be dropping, we need to showcase that we know that. You see, that's why this is just a 1 mark. So for 1 mark, there we go. The wind speed is expected to drop by 0.46 kilometers per hour. You see, just don't overthink it. Don't overthink it. Moving on to the next question. We are now working on question number 2. Question number 2, what does it say here? The days, oh, grade 8, talking about grade 8. Okay, back in the day, back in my day. Anyways, question 2, it says the number of days that grade 8 learners were absent at a certain high school during a year was recorded. Okay, and then it says this information is represented in the table below. So here it says number of days absent and number of learners. So obviously days absent, this is like days from 0 to 5. You had 34 learners that were absent roughly between 0 to 5 days, where the 5 is not included. You see, remember this is saying less than 5. You see, so this is numbers between 0 and 4 technically, because you cannot be absent for like 5.9 days or something. You see, so here just keep in mind that here this is telling you that 5 is not included, meaning here people that were absent for like 5 days, they are falling under these 45 people here. So let's just keep that in mind. Okay, let's just keep that in mind. So to interpret this table, we can already see again, you see, people that were absent between 0 and 5 days, there are 34 people. And then between 5 and 10 is 45, going on and on and on. And then guys that were absent between 25 and 30 days, that's like 3. So for 1 single mark, they're asking what is the modal class. So remember, modal, as we have stated already within like the stats playlist on the main channel, modal class, we know that refers to like the most. You see, most. So the modal class, you see here, look at this, you see, this here is the class, school class. This data here, these are the different classes, you see, 0 to 5, blah, blah, blah. The modal class is obviously the class that has the highest amount of learners, which is this class here. You see, that's the modal class. There we go, nothing crazy here. 1 mark, you move on and you keep on moving on. You see, you run, don't look back. How many learners were absent from school for less than 15 days? So people that were absent from school for less than 15 days. Oh, this is quite interesting. So people that are absent for less than 15 days, I mean, this is not difficult, because you see, people that were absent for less than 15 days, technically speaking, I mean, if you look at our table, guys that were absent from 10 to 15, excluding 15. So people that were absent for less than 15 days, we technically include these guys here, these 98, because all these 98 people, these were people that were all absent for less than 15 days. Also, these 45 here were absent for less than 15 days. And then these 34 here, they were also absent for less than 15 days. So here when they ask how many learners were absent from school for less than 15 days, you consider all these guys in this class, and then this class and this class. We consider ones in this class because you see, ones in this class It's everyone that was absent between 10 and days less than 15. So let's add up those three numbers: 98, 48, 45, and 34. All this in the calculator, our favorite instrument in a math exam. Or is it? I wonder. Is it really our favorite one? Or is it just favorite though? Why do you have to have favorites in an exam? Anyways, all this in the calculator is like 177. So yeah, 177 learners were absent from school for less than 15 days. Okay, not so bad, I guess. Or is it? I don't know, man. I don't know. Anyways, let's move on. So how many grade 8 learners are at the school? Oh, what a wow, guys. Like these guys, they want to give us free marks, but it's okay. It's okay. So obviously we have counted the first set here to be what? 100 and what? 177. 177, bruh. Come on. Say things nice. What is 177? What is that? What is 177? This guy, it's 177. Goodness. Just say the words, okay? Just let the words come out of your mouth. But anyways, let's see here. What else? Okay, so with this 107, I'm doing it again. 177. Hey, plus the 43 here, and then plus the 7 here, plus the 3 over there. Oh, this is technically 10 plus 43, so that's like 53. And me, I'm like here. I'm itching to like double check that in the calculator, even though I know it's 100% correct. It's so funny. Okay, it's not funny. It's just like dumb. It's like, my guy, come on. It's 53 plus. It's 43 plus 10. It's a 53. Just deal with it. So in the calculator, 177 plus the 53 over there, what you get? 230. So 230 is the amount of learners at the school. Oh no, the amount of grade 8 learners. How many classes would these be? If you have like 30 kids in a class, let's see how many grade 8 classes these are. Let's just see, just out of curiosity. If each class had 30 learners, that's like close to 8 grade 8 classes. The school is huge. It's too big a school, but it's cool. It's cool. For 4 marks here, they said draw a cumulative frequency graph. So already we have stated, if you can recall from like the stats course, a cumulative frequency graph is just an ogive, or as we like to call it, because we can. I mean, look, this is give, and there's O right in front of it. So what you call it? An ogive. These people that call this an ogive, they can go jump. I'm gonna call it an ogive until the day I drive a G63 AMG. So the day I drive a G63 AMG, just remember, I will not be calling this an ogive anymore. I will start calling it an ogive. But anyways, for 4 marks, they want us to draw a cumulative frequency graph. Oh yeah, they say ogive here. Okay, well, it's fine. Draw a cumulative frequency graph to represent the data above on the grid provided in the answer book. Okay, so if you're gonna draw an ogive here, you need a third. You need like a third column here to help you, and that column we call it the cumulative frequency column. So let me move this inwards. Move it inwards, because here we want to draw a third column that's going to help us answer our question. Because if you're going to draw an ogive, you need a column that is going to show you the totals of this data. So let us just draw that third column. Freehand is not working. Let's finesse this thing. Perfect. Now this third column that we have created here, obviously in an exam you also want to create that for yourself. You don't have to really create it and make it look nice or everything. No, just make sure it's there. So here you can put your cumulative frequency. So your cumulative frequency, all you do is you're adding these one by one, and then you just stacking it over there, stacking it. So here it's 34. You're starting with 34. So 34 is what you're starting with. And then you add 45. So 34 plus 45, let's see, 34 plus 45, you're going to get a 79. So you get a 79 over here. And then what? And then you add a 98. Let's just remove this before it confuses people when they're looking at the memo. So the 78 plus the 98 over there. Let me just make sure I don't make a silly mistake. So if you spot any silly mistakes, please let the boy know so the boy can correct it, you know. The boy is not a robot, so the boy is bound to make silly mistakes here and there. So yeah, you know, be that person, you know, that's gonna be like, bro, you made a mistake over here. And then I'll be like, oh, thank you so much, oh my gosh, you're such a star. And then I just fix it up on the memo and stuff, you see. So yeah, man. Anyways, 220 plus 7, it's gonna be 227 plus the 3 there, we get about 230. So you see, these are just, you know, they're just stacking, you know. It's like how money stacks up, you know. You get some more, you get some more, and then it keeps stacking. Keep it stacking. Anyways, now that we have this data, we can easily draw our cumulative frequency polygon, because with a cumulative frequency polygon, let's just draw our two axes here. There we go. So I mean, with a cumulative frequency graph, you see your cumulative frequency always goes on the y-axis, always and forever. You see your cumulative frequency data always goes on the y-axis, and then your class intervals, which are these stuff here, those go on the x-axis, always and forever. So let's just put that data here. So here we have from 0 to 30. So these can go in like 6s, or can they? Let's just see how they're going. Yeah, they're going in 5s, so why not just do that? Like, come on, bro, like, you know. So if they're going in 5s, we can say here 0 and then 5, 30. See, 5. With all this space, I'm literally thinking to myself, why am I making it small, bro? Why are you thinking small? Okay, no, I'm not thinking small. I'm gonna make it bigger all at once. You'll see. So here, this is from like, you know, roughly a 30 to like 230. So we're just looking for a scale here. So it looks as though going in 50s, going in 50s looks like it's gonna be okay-ish. Yeah, let's go in 50s. 50s look like they're going to be fine. So yeah, 50s look like they are going to be fine, or are they? Yeah, 50s should be fine. 50s should be fine. So let's see here. Let's maybe do that. 50 there. 50s though. Hey, yeah, nah. Let's see what this is gonna be. 50. Okay, these look okay. I mean, if we had to go in 30s, yeah, I mean, the one thing I also don't want to try and I don't want to make it seem as though the scale is like too much of a big deal. Just choose something that is going to work for your data, you see. So here, I think even me pivoting to like using 30s, I think that should be fine. Let me just pivot to using 30s. I mean, like, why not? You know, why not? Why not? So here I'm going to use 30. Yep, 30s look like they are a bit better. So you see, now that we have drawn what we have drawn, we've drawn our scales. So obviously on your answer sheet, you'll have all this. So that's so lucky. And we said here, always put your class intervals down here. So here, what are those called? These are number of days absent. And then over here, you got what you got over there. You got the cumulative frequency. So you legit call it cumulative frequency. Like, would you believe it? Or rather, you could just call it number of learners. Yeah, number of learners. Because you see, your cumulative frequency data is talking about the number of learners. You see, 34 going on and on and on. And then you see here, we use these two columns to like plot. You see, now all you do is when you're plotting, be careful to plot based on where this is. What I mean is, you see, from 0 to 5, it's 34. So what that means is where 5 is, you go there and then you estimate where 34 would be. So if you think of it like that, where 5 is, 34 would be like just above the 30. So it's like somewhere there. You make a point. You see, you always make a point here at the 5, 10, 15, 20, 25. You see, that's why here our x-axis here has to be determined by this data. You see, 5, 10, 15, 20, 25, 30. Let's see here, 5, 10, 15, 20, 25, 30. Perfect. And then, so here, 5 is 34. And then 10 has to go with 79. So 79 would be after 60. And then in the middle is like 80. So there. Perfecto. And then you keep plotting. You keep plotting. So here, 15 has to go with 177. So let's see here. 15, where's 177? Well, that's like just before 120, so that's like somewhere there. And then, yeah, let me just carry on plotting and then we'll just carry on. Yeah, so it's like what? 20 and 120. There we go. We have plotted all we can plot. Now, I'm just going to make a minor adjustment to this one here because of the sake of us making sure that our data goes exactly to 0. You see? So anyways, let me just drop that a bit because 34 should be like somewhere there. So once you've plotted all your points, you see, if you're going to draw your ogive, your ogive always has to go down to 0. So here, plot your data. You see, you can even sketch it. Don't use a ruler, please. Like you will cry. So here, just make it smoothish. You know, it goes down like that, and then you can even start to take it from the 0. You see, take it from the 0. You see, take it from the 0, and then you join it like that. You know, just just be artistic about it. Okay, just don't be like, don't jumpy. So just come on, what am I doing? Just make it smoothish. If it's not like 100% smooth, that's okay. That's like totally fine. So you see here, I'm even finessing this a bit, you see, because I want it to be smooth. Okay, I want it to be smooth. So you see, we want it to be smooth like that, and then you can just, plot stuff, like they, and then this one. Yeah, like this should be fine, because mine is freehand. You see, things may not necessarily be like 100% there, but it's okay. This is 100% fine. So you draw your ogive and then you keep things moving. So let's see, the next question here, they said use the cumulative frequency graph to determine the median number, the median number of days the grade 8 learners were absent. So you see, things like these, like I kid you not, you see, the stats course, we go through stuff like this galore. Super many questions. Super many questions. Hey, what a wow. Hey, I'm gonna start saying that a lot. Super many questions. Am I really trying to like cover up for that blunder? Hey, I don't know what I'm trying to do, but it is what it is. Use the cumulative frequency graph to determine the median number of days the grade 8 learners were absent. So getting the median number of days, you always use your cumulative frequency side. You see, this is the side you use. And remember, our maximum is somewhere over there at 280. Clearly, if you can recall from what we have already mentioned, also this is like in the statistics playlist on the main channel. The median, you can find the position of the median by using this formula. You see, this formula here is going to give you the position of the median. You see, it's just going to give you the position of the median, of which the position of a median is determined by the amount of data we have. So here, n is the amount of data that you have. You see, here we're dealing with 280 learners, so n is going to be 230. I didn't know I said 80. I meant 230. I'm sorry. I meant 230. Okay, I meant 230, but I really shouldn't be so extra because I'm pretty sure you understand. I'm pretty sure you're reasonable. If you're not, that's your baby. That's on you, man. I ain't gonna judge you, I promise, you know. So obviously, I mean, this is a totally new question, so obviously you may want to clear your calculator as well, just so that you can be free to use it for what you want to use it for. So shift 9 all again, blah blah blah. I want to put here, let's see, 2/4. So the median is at position 115, 5. Is it 115, 5? Where is it now? Ants 115, 5. Yeah, that's where the median is. You see, let's just put this here, 115. This is where you find the median. You see, we haven't gotten the median class. You see here, they say we should get the median number of days. So we're gonna, for you to get the median number of days, you first need to get the median in terms of learners first, and then trace it to your graph, and then trace it down. You see, all this is covered in the course. Like, yeah, I'd recommend taking the course. But obviously, if you've gone through a few questions on this channel as well, then you're woke-ish. You know, you're like 30% there. Let's say 50%. Yeah, I don't want to diss anybody, but no. What I meant is that obviously on the course things go a bit deeper, so you'll be able to understand better, because yeah, it's lit over there. So 115 would fall. Let's see what's in the middle of 90 and 120. 90 plus 120 divided by 2. So in the middle of 90 and 120, that's like 105. So just above that. So somewhere there is going to be 115. Well, but that's like in the middle. So just above the middle. So this is where 115 would be. So you 115.5, I mean, you see. So this is going to be there. You trace it to this thing over here. But then this is not as straight as possible. There you go. And then you trace it down to your number of days. So this one is going to be super tricky. Like, oh my goodness. Ha 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 ha. Wow. I am so regretting not having like a 100% scale type of thing going on. So, I mean, wow, man. Why are you landing here? You're literally landing in between a rock and a hard place, man. Like, let me just make some adjustments. Okay, so after some adjustments, this looks like it's going to be between 10 and 15. So you see, if they say use your cumulative frequency graph, right, what they mainly want to see is, you see these dotted lines here. But then there's a hack. Instead of using your cumulative frequency hack, I mean, instead of using your cumulative frequency graph, you can just put these dotted lines to show calculations. But then what you then do is, you see here, 115.5. What you do for yourself is you go back to your data and you ask yourself, if you keep adding these learners up, you see, if you add 34 learners and then you add 45, you see, by the time you add 98 more, we know that between you adding 45 and 98, that's where you are going to get the 115th learner. What I mean is, you see 34 learners and then you get 45 more, you'll be dealing with like 79 learners. You see, by the time you add 98, you're already dealing with like 177 learners. So you see, 115 is definitely going to be within this class over there. You see, that's why you see when I was doing it, I even had to do some adjustments, because you see, between 15 and 20, that was not going to make sense. You see, because between 15 and 20, you're already at like 220. You see, that's between 220 and like 177. So for 115, you see, it's between 79 and 177, of which 115 is past 179. So you're gonna get that in this class there, between 10 and 15. You see, so them wanting you to use your cumulative frequency graph, they just want to see the dotted line stuff, you see, and then they want you to see that your data is actually landing between 10 and 15. So when they're asking for the median number of days, you're gonna say the median number of days is between 10 and 15. So here, so the median number of days, we have clearly seen that it is bigger than or equal to 10, and it is smaller How done 15? Perfecto. Nothing crazy, nothing major. You are move on. We are here at question 3 and we want to answer analytical geometry questions. Yeah, it says weird when it's like a new question because the thought will always be like, okay, so how do we start? Yeah, well, we have started. So here it says we no, they didn't say we, they said in the diagram S. So yeah, you see, we're gonna zoom out here so we can see the sketch, because the big idea with working out what you may call working out what, yeah, the big idea with catch your breath, bro, catch your words. The big idea with like analytical geometry questions, né, is that you need to, like, while reading the question, you need to be analyzing the sketch. Don't just read the stuff. Don't ever read this like a paragraph. That doesn't work, you see. Don't even worry about reading it once and then reading it again while analyzing. No. From the beginning, just read while analyzing the sketch. Like here they say it in the diagram. S is this point. You see, even when I read this, I was automatically thinking, where is S? Like, what are they talking about? And then it's like, you see, now we've found it. It's right over there. Perfect. They said S, L, and Q. You see, you trace those points. L is over here. Q is over there. These points are the vertices of S, L, Q. Okay. S, L, Q. Fine. They said here they are the vertices of S, L, Q having LQ perpendicular. You see, these things here, don't take it for granted. These guys did not waste their ink telling you that this is perpendicular, or showing you that it's perpendicular, you see, or showing you that this is equal to that. They didn't waste their ink by doing that. So don't take it for granted, please. They say this is perpendicular to SQ, fine. And then what? They said, yeah, SL and SQ. Where is SL? You see what I did there? They said it and I'm already looking for it. So they said SL and SQ are produced to points R and M. Yes, we can see that. This goes to R, the other one goes to M. And then it says, yeah, respectively, such that RM is parallel to LQ. You see, these things here, don't take it for granted. Don't just read them. You see, I'm trying to emphasize that the issue I've seen, right, whenever I'm like giving like a Zoom session or whatever, and then I ask someone to like read the question, 99% of the time they just read it, you know, whereas I'll be trying to see, are they going to analyze while reading? Are they just going to read? Or, yeah, and 99.99% of the time, actually, honestly speaking, almost like 100% of the time, people just read it like a paragraph, which is like the worst thing to do. Never just read a description like it's a paragraph, because it's not a paragraph. Okay, like it is. I don't know what a paragraph is. Is a paragraph just like words and sentences and what? Yeah, the point is, it's not a novel, you know, it's a description. So anyways, these lines are parallel. It says here SM produced. Where is SM? Where are you? SM produced cuts the x-axis at N. Yeah, let's see here. Yeah. Go back. So this is N here, and then here it says, yeah, N is this coordinate, or QM is equal to MN. Where's QM? QM is equal to MN. Let's color code that, you know, maybe give it some pink colors to support, you know what. So this is pink over here, pink over there, and then here it says what? T and P are the y-intercept. Where is T and P? You see, I want to emphasize how you can see I'm like going super slow with the description here, because the description is everything. If you analyze your sketch well, if you read your description well, remember all this information is getting in your head. And don't underestimate your subconscious. Your subconscious is super powerful. That thing is a beast, man. That thing is a beast. So use it. So anyways, here it says yeah, this is the y-intercept of this straight line here. This is the y-intercept of this straight line. And these two straight lines are parallel, meaning they have the same gradient. So with all that we have done here, all the analyzing, we're good to go because, yeah. For 2 marks, they say calculate the coordinates of M. Well, I mean, come on, bro. Come on. Like, this is, in an exam, these are the nice questions, eh? They want us to get the midpoint. Just using the midpoint formula. It's fine. You take those, you get those marks and you run, okay? You get those marks and you run. So here, obviously, M is just the midpoint of NQ. So that's just the midpoint formula, nothing crazy there. There you go. N and Q, you can label those X1 and Y1. It really doesn't matter how you label them. Perfecto. Now what? Now you throw in the information, you see. So obviously throwing in the information, it's like negative 8 minus 0 for the y's, and then here 4 minus 8 for the x's. So our coordinate of M, this, I don't even know why I put NQ there. You can just put M, just so that things are straightforward. So here we said what? 4 minus 8. And then this one, what you get? Negative. Wow. Well, okay, I did mix them up, even though it's not a big deal. I think for the sake of the memo, let's not do that. You see, 8 here plus that, and then here 0 plus that. It doesn't matter. I'm just trying to match it to what I wrote over there, I'm trying to be a person of my word, man of my word. I really am, though. Anyways, so let's see here. This simplified, this is what we're gonna get. There you go. Nothing crazy, nothing major. But because you've gotten that piece of information, throw it onto your sketch. You see, that's one thing we always emphasize in the analytical geometry course. Once you get a piece of information, use it as if it is information that was given. You see, you have this piece of information now, you're gonna need to use it. So anyways, here the next question for 2 more marks is they're asking for the gradient of NS. You see, these questions here, don't ever lose marks for questions like these, because it's just like, how are you going to lose marks for something like this? Like, no, please, no. But anyways, here you just need your gradient formula. It's also on your formula sheet. So anything that's on your formula sheet, that's straightforward. You can already see it's not worth a lot, but at the same time, yeah, don't lose those marks. So gradient is given by this. Now, obviously, you can just, it doesn't matter how you label them. Here, I'm just literally going to take negative 16 minus 0. And then also 0 minus 8. Gradient, the gradient, there's a positive 2. Nothing crazy here. Let's keep moving, Try and get to the hard stuff quickly. Here it says, show that the equation of line LQ is this. So just try and use this as a way to mark, you see. Just pretend they asked for the equation of LQ. So whatever you do, just get the equation of LQ and then just check if it's going to be equal to this. Now let's look at where LQ is. Where is LQ? Oh, there's LQ. So the nice thing with LQ is that LQ is perpendicular to this line that we have just gotten a gradient for. You see, we've just gotten the gradient of SN, and we need the gradient of LQ because you see, here they're asking for the equation of LQ. So automatically you know that y is equal to mx plus c. And we know that the gradient of LQ times the gradient of NS, because these lines are parallel, because these lines are perpendicular, this calculation should give you a -1, you see, because they are perpendicular lines. So we want the gradient of LQ. So the gradient of LQ times the gradient of NS, which is just a 2 there, we're going to equate this to -1. Of which, if you divide by a negative, if you divide by what? What are you trying to work out? You're trying to work this out, ne? So you have to divide by 2 on both sides, you see. So this cancels that. The gradient of LQ is -1/2, which is what we're seeing here. So that's perfect. And then here, you can just use this formula to get the full equation. So in this formula, obviously this is just gradient, and then y1 and x1 just represent a coordinate that the graph passes through, of which LQ, the coordinate that it passes through, you can choose Q here, which is just 4 coordinate -1. So Q here, 4 and -8, sorry. So these ones here, this is what you can refer to as x1 and x2, you see, for the sake of this formula. And then let's see what you're going to get here. Because you see, a minus and a minus give you a +8. So for the sake of the memo, let us just not do funny things. This is just a -1/2. There you go. Now obviously here, what you want to do is, what do you want to do? You just want to isolate y. You see, if you take the 8 over, you're going to have 2 minus 8, which is definitely a -6. Perfect. You get those marks and you run, baba. You see these easy things here. Just use them to bank marks. You bank your marks, you bank your time, but you keep moving, you know. For 2 marks here, they say determine the equation of a circle having center at O. And then it says here, yeah, having center at O, which is the origin, and also passing through point S. So because it's passing through the origin, you know that the standard equation of a circle, as we have already showcased in like the analytical geometry playlist and the analytical geometry course, we have stated that the standard form of a circle looks like this. You see, now they said the circle is at the origin, so it means this is a 0 and this is a 0, because remember, A and B just give us the center of our circle. So far all we need is our radius and then we'll be done. You see, they say the circle passes through S. So this is quite interesting. I mean, this is the I was about to say the dumbest thing ever, but that was just going to be a bit too harsh. So this is S and then this is O, you see. So if your circle has a center here and it passes through S and you need the radius, all you want to do is, this is a coordinate that the graph passes through. You see, it's an x and a y coordinate. So you throw it into your equation and you solve for r, you see. So S, what is this here? It's 0 and -16. So where x is, you know, that's a 0. This is a -16. Let's get r. So 16 squared. That's one thing I actually have no idea of. You could have asked me 15 or 14, even 14. What is 14 times 14? Out of curiosity. Okay, that's like 196. But we want 16 times 16 because that's 16 squared. 256. Oh, okay, yeah, of course. But me, I had forgotten me. But anyways, this here you get that square root of that is just back to 16, which is okay. So you square root the right, you square root the left, and your value for r is just a 16. Perfect. So here you can then say, therefore, this is going to be the equation of your circle. You can write this as 1 is 256 or 16 squared. It's totally up to you, man. It's totally up to you. This here for 3 marks, they want the coordinates of t. Okay, where is t? Where are you, t? We want to find you. Where's t? So the big idea with the analytical geometry course is that it has 3 chapters. One of the chapters, it deals with sketches like these. You see, that will be sketches but no circles are given. And then another one deals with scenarios where no sketches are given at all. And then the third chapter deals with like sketches that do have circles to begin with. So you see, it will help you practice 100% for tests like this. I mean, I feel like guys that went through the analytical geometry course, this analytical geometry section was like so simple, like so simple. But anyways, t is the coordinate there. T is clearly the y-intercept of this line over here. Now them asking for t, it's a 3-mark question, so we obviously don't want to overthink anything. Like, we really don't want to overthink anything because what? I mean, it's just 3 marks. And the issue with t is, I mean, you can even get a free mark to begin with. T, whatever this coordinate is, we already know that the x value is a 0. I mean, like that we know already by default. You see, we just need the y. We are not done here. We just need the y value. So luckily, I mean, it may seem funny or weird, but the easiest thing you can do for yourself is to just get the y-intercept of the line RM. You see, use the line RM to get t, because if you think of the line RM, you already have its gradient, which is just the gradient of LQ. So you have the gradient of this line. So you can just use that. Might as well just get the equation of RM. Get the equation of RM, because in the process you'll get T. So here, the equation of RM, let's put here Y, referring to the equation of RM. We know that this is equal to, what's the gradient of LQ? The gradient of LQ, we got it to be a -1/2. So here we know that it's this plus C. You see, we definitely know it. So obviously, to find the y-intercept of this equation, the y-intercept of this equation is going to give us this over there. Might as well change this to a C, you know, to be funky, you know, to be fancy. Because remember, the y value of T is the y-intercept of our straight line here. Not to say this is the only method, but it looks like the most viable one. Probably there is another method, but I feel like this is the only one that's viable. If you find another one, that's perfect, you see, because who knows if there is only one method for this question. There could be 20 billion. I'm lying, not 20 billion, that's too many. But anyways, let's just carry on here. Let's not waste time. To get C, we can throw in a coordinate that the graph passes through, of which that one is easily given. We have M. We've worked out M. You see, it's just 6 and -4. So where X is and where this is, there you go. So T, no ways. I refuse this answer. No ways. Where is T? Oh, no, I accept it. It's down here. So yeah, that does look like a -1, because I thought it was up there. So I was like, no, universe, I did not take this. I do not want it. Take it back. But no, we accept it. We accept it. Thank you very much. Thank you very much. So here it's like T is just 0 coordinate -1. Perfect. You see what we showcased just now, you know? When the universe throws you something you don't want, refuse, Baba. Refuse. Deny it. But then obviously if it's a mistake, just apologize and accept it. Okay? Anyways, so that's T. For 3 marks here, they said we should determine LS over RS. So there's LS over RS. Interesting. Why is Euclidean geometry showing up in analytical? I thought the Euclidean geometry section is all the way down here. Why? You see, this Euclidean, it couldn't wait. Just couldn't be patient. But anyways, they said we should determine the ratio of LS over RS. So let's look at where LS and RS is. Let's try and see where the catch is. There's where's S? LS and RS. Ooh, apapalele. How many marks? 3. Well, it's only 3 marks, so this should be comforting. Oh, this one should. Oh wait, no. I think I reacted too soon, because the ratio between LS and RS, this is what you want to think of. You see, obviously in a situation like that, you want to think of how you have a triangle here, which is RMS. This is clearly 90 degrees. The reason for that is, you see, these are parallel. So obviously these are corresponding angles. Perfecto. And then you have another triangle inside it, which is definitely similar to it. This one here, you see, there's L here, there's Q here, and then there's S here as well. 2 triangles, and the key thing here is that these 2 are parallel. So you want to be thinking of your proportionality theorems here, because your proportionality theorems, they will help you answer this question. Because our question, let's actually deal with it here, because I mean, why not? We're answering a question where we're gonna, but the calculations are supposed to be down here. Okay, let's just finesse this. Oh no, let's not. Let's just think clearly. So here we're saying that, you see here, we need to be thinking of our proportionality theorems and all that stuff. So this here has got to 90 degrees. Let's just put that there. Perfect. So in our case, we want, what do we want? LS over RS. So let's just get LS over RS. So LS over RS The thing with LS over RS is LS is in the small one, RS is in the big one. So what you want to think to yourself is that if you think of LS and RS, you see those are somewhat corresponding sides, because where you're talking about LS for the small one, you will definitely be talking about RS for the big one. So for you to get that ratio, literally all you can do for yourself now is look for any other side for the small triangle where you can get its length, and then also look for the corresponding side of the big one where you can also get its length. What I mean is, just looking at what they've asked us to do here, we already know that just looking at this, right, LS, which is the small one here, over RS, or rather write this the way it is written here, LS over RS is equal to, let's use a side where we can get lengths for. This is equal to QS over MS. You see, our reason will be proportionality of similar triangles, and then we have to specify that LQ is parallel to RM there. You see, so this that we have just written down here, we need to make use of it to answer our question, because the fortunate thing is, you see, we can get lengths. We just need to get the length of QS and MS. You see, getting QS and MS is quite easy because we can just use our distance formula. You see, QS here and MS are there. So let's just use the distance formula. QS first. QS, you are up. Give us your distance. We will use the distance formula. So here QS, you don't have to write out the distance formula. You can just immediately use it. So in our case, what is Q and S and M there? We need those coordinates. Okay, so our points, we can clearly see them there so that we can put them into our distance formula. So the distance formula is obviously on your formula sheet, so don't get it wrong, and don't worry about putting the x's first or the y's first. It really doesn't matter as long as they're like, you know, corresponding and stuff, because you're gonna have two values here squared and then plus two values here squared. X is in here, y is in here, so it's like, if it's like x1 here, here it should be y1. If it's x2 here, this should be y2. So we're using what, q and s, you see. So let's see, q and s here, we can just say 0 minus the 4 there, and then here negative 16 minus 8, that would be a plus. And then just put this in your calculator, you know, don't waste your time, just put it in the calculator. That is giving you 4 square root of 5, which is like, okay, fine, we'll take that answer. And then what else do we need? You see, here we've gotten QS. Now we just need SM. You see, SM is using S and M over there. So it's huge. Let's just get another color. I feel like these colors are now, yeah, we'll change colors just now, you know. So we need what? SM or QM. I mean, SM, MS, whichever way you call it, it really doesn't matter, to be honest. So with SM, we can also do the same thing. You see, these are their coordinates. So here we can say 0 minus 6, and then negative 16 minus 4 there, minus negative 4. Okay, perfect. So what we do now, what we do. The issue here, let's see. Oh, calculator. I was about to work it out with my head. I was like, hey, my guy, this is not an NBT. Use that calculator, baba. Use it. And yes, if you're looking for an NBT course, guess what? The course platform has got you covered. So do the things. Putting all this into the calculator, let's see. This is 6 square root of 5. Whew, there we go. So you see, with all that we have done here, we have just made our lives so much easier. You see, because here we've gotten QS, here we've gotten MS. So I mean, just for the sake of the fact that I wrote MS here, might as well, you know, because why not? Anyway, so yeah, QS we have, MS we have, and it's the same as LS over RS. So here we can say, therefore, these, according to our calculations, is just 4 square root of 5 at the top over 6 square root of 5 at the bottom, of which the square root of 5 is what happens to them? They cancel, and then the 4 over 6, that can be simplified using your calculator. Perfect. Push it to the limit. But anyways, moving on. Nothing crazy here, nothing crazy. This question was quite interesting, I think. It just showcases that, you know what, with math, don't limit things. Even if you're dealing with analytical geometry, don't think to yourself, I should not think of Euclidean or whatever. Doesn't matter. I mean, if you saw paper 1 of these supplementary June exams, you saw there was trigonometry there in that sequence. There was trigonometry in that sequence in a series question. So yeah, man, don't be surprised. Here it says for 4 marks, we should get the area of PTMQ. Whew, yeah, going all the way up here. PTMQ. Let's see here. PTMQ, just so that we don't get it wrong. Let's see, where's PTMQ? Where is P T M Q? Oh, they want the area of this thing here. Well, this is a trapezium americano. Let's see here, trapezium iso. Well, getting the area of this trapezium is quite interesting. Like, wow. Because funny enough, getting the area of a trapezium, this has like a specific formula that you use. And you may be thinking to yourself, bro, how do we even get this? Because I mean, we don't have, it's okay. So let's make things easy for ourselves. This is the formula for the area of a trapezium. The area of a trapezium is always a half. Actually, you know what? Forget the area of a trapezium, because that's kind of a bit too far-fetched. You know, let's keep things simple here. If you're going to get the area of this tiny space over here, right, obviously you want to consider how you have 2 triangles here. You see, you have 2 right-angled triangles. So obviously you can get the area of the big one here, which is TMS. And then guess what? You subtract the smaller one, which is PQS. You see, you're going to take this one and you minus that one. And there we go. Things are looking up. You see, there when I was thinking of trapezium, I was like, but wait, why am I thinking of the formula for a trapezium when we are in grade 12 and we're in South Africa, you know? So here, T, we worked it out to be 0, coordinate 1. This is P. We may need the coordinate of P. Yeah, I think we need the coordinate of P at least, you see, for us to eventually then just, you know, work stuff out, because yeah, we definitely need it. So the area of this triangle here, I mean, MS, what did we get for MS again? MS, we got it to be, was it what? 6 square root of 5. So here, let's put MS. How many marks is this question? 4. Wow. Yeah, these people, they're so stingy. So much work just for 4 marks. This is not fair. But anyways, let's not be lazy. So we have MS, we also have PSQ. The only things that are, we have these as well, because this is just on the y-axis, you see. So you can just compare the y values here. So let's just get P first, you see. It feels like our only mission here is to get P, because the rest we have, you see. Oh yeah, let me not be lazy as well, you know. So MS is 6 square root of 5. Perfect. And then what else do we have? We have QS. And then for us to do, wait, half base times height. Yeah, we need the hypotenuse. So yeah, might as well get this, because we can then just use Pythagoras to get these here, because I mean, using the distance formula for those, I don't like the distance formula. It just feels so boring, you know. It's like, but anyways, getting P, we can just throw, what we know about P is that the x value here is a 0, you see. So to get the y, we can just use our equation of LQ. Remember, we have the equation of LQ. Oh, so we have it already. Because if you have the equation of LQ, it means you already have the y-intercept of your line there. You see, because this, you see, this here is giving you P. It's a gift from the universe. So we have P. We have P now, so it makes life so much easier, because I mean, we just need yeah, what I'm gonna do is, you see, we need the perpendicular height, so we need this here and this here to put into our half base times height formula. So in my opinion, instead of me using the distance formula to get this and to get that, I'm just gonna eventually use Pythagoras, because I think it's quicker, it's easier. Well, it's the same thing actually, because here technically what I'm trying to say here is, you see, between T and S, I mean, look, the y value here is a -1, the y value here is a 16. You see, yeah, it's -1 and -16. The distance there is 15. You see, so TS is 15, that we already know. And then PS, we're going to use the same analogy, you see, in the sense that P here, the y value, we say it's a -1, no, 6. Why did I say -1? Like, goodness, bro. It's -6 here, and down here we have a -16. So the distance is 10 units there, because remember, distance is always a positive. Distance can only be a positive. So this is just a 10. So getting dimensions here, we can just use Pythagoras theorem. It's exactly the same as the distance formula, funny enough. So here we can say TS squared is equal to TM squared plus MS squared. And then we want TM on its own, so guess what? There we go. And then obviously you can square it both sides. And I'm deliberately isolating TM first before I throw in values, you see, because I'm trying to showcase that you can definitely do that. You see, don't be afraid of doing it. It is normal. So TS, let's see, TS is just a 15. MS is 6 square root of 5. And then you just put all this into your calculator. Dear calculator, please give us an answer. Okay, 3 square root of 5. Well, it fits the others, so that's TM over there. And then here we need PQ, right? So yeah, the only issue here, you may be thinking to yourself, but bro, it's out of 4. Why are we doing so much work? Yeah, you know, it is how it is, man. Don't be lazy, you know. I'm not trying to diss you or anything, but sometimes, you know, sometimes life is just like this. So here we can also get PQ here. So here, I mean, like I said, we could have just used the area of a trapezium, but you know, that's not like something that's like widely used in like our textbooks and all that stuff. So let's leave it alone. So here PS squared is going to be equal to SQ squared plus PQ squared. PQ. PQ. Anyways, here let's isolate PQ, or let's just throw in numbers first, you see. Let's do it differently. Or why do it differently? Just do it the same, bro. Come on, be consistent. So here PQ stays here, so this has to go to the other side. There you go. There you go. So here we can just throw in values now, you see. And then what you got now? What you got? Yeah, let's throw all this into the calculator, because we can do that. 2 square root of 5. Yeah, so this feels like a theme here, eh? Square root of 5 this, what square root of 5 that. So 2 square root of 5. Now we have all our dimensions, so let's just get those 4 marks. You know, it feels like, hey, being overworked here just for 4 marks. But it's cool. It's cool. It's cool. It is what it is, bro. It is what it is. So here you see the area here is just half base times height. The area here is also just half base times height. So let's just put those in there. So here, yeah, genuinely speaking, even me, I'm just like, bro, for 4 marks, like, come on. But anyways, we're at the end now. So this is just a half our base. You can make your base whatever you want. Here, let's say 6 square root of 5 here. And then perpendicular height is TM. So TM was like 3 square root of 5. You see, the area of this triangle here, we said we are subtracting the area of this triangle over there. I need another color. What you got? I got blue. That will work. So here, this one is just half. What's the base? You can make it this one. Perpendicular height, you can make it that one. PQ. So PQ is like what? 2 square root of 5. There you go. Oh, could have also used the area rule. Like, oh my gosh. Wow, I just think of that now, bruh. Because look, we have, oh no, never mind. We really couldn't have. Okay, no, stop, please. Like, what the hell, bro? Come on. Come on, bro. Don't embarrass yourself in front of all these people. Like, what the hell? But anyways, let's put this into our calculator. Whew, the satisfaction of getting a normal answer. It's like 25. Like, wow. 25, you can say 25 units squared, you know, just to sound fancy. If you just say 25, that's still 100% fine, you see, but you won't be sounding fancy. And like, you know, sometimes you gotta, you know, go the extra mile. But anyways, that's that. We're done. You see, I even gave myself a gang lot of space. I think I beforehand knew this question. I think they just made it 4 so that people don't lose a lot of marks for that question. So anyways, we're now at question number 4. What are they asking us? You see, we said always just analyze your sketch nicely. And remember, we said in the analytical geometry course, you have chapters, right, which deal with sketches like this, and then you have chapters which deal with sketches like these, where they would have given you a circle to begin with, and then chapters which, not a chapter, lessons, because it's 3 chapters in total. One of the chapters has circles like these. The next chapter has, you know, sketches just like this, and then the third chapter has no sketch at all, meaning you'll have to like draw your own sketch and stuff like that. So those are the 3 chapters in the analytical geometry course, because as mentioned, for all the topics there's a course for that on the course platform. But anyways, here it says in the diagram, P is a point. You see, we have read it. You go look for it. So here P is a point. Fantastic. It is a point. In the diagram, P is a point of the circle. You know, is the center of the circle. Yo, wow. My reading bundle is shaky. Here it says V. V is K coordinate 1. Okay, where is it? Over here. Okay, fine. So it looks like V. Let's see what else they say about V. Yeah, V is this point, and W are the end points of the diameter. You see, I wanted to confirm. So here they say these are the end points of the diameter. So W and V are the end points of the diameter. So remember, this line here is not a tangent. Don't mistake this for a tangent. It's not a tangent because it's not touching the circle here only. You see, it's cutting the circle. Remember, a tangent is a point that does not cut the circle. It has to be just touching it. This is not a touch, you know. This is a curve, is a cut. It's not a touch, it's a cut. But anyways, yeah, we have a diameter here. So I was already looking for some diameter and tangent laws and whatnot, but you see, we don't have that, even though that's like Euclidean. You want to think of that. And then here it says the circle intersects the y-axis at B. So where is B? B. So all this is super duper intentional. You see, it's not called analytical geometry for no reason. They could have just called it geometry, you know, but they called it analytical geometry. Because why do you think they do that? Because they want you to analyze the sketch. If you don't analyze, then you're gonna cry, okay? And we don't want you to cry, you know, because crying is not good. I'm like, you are bored crying and stuff, but that doesn't mean you have to cry through life, you know. Come on. Anyway, so here it says B and C are the points on the y-axis, and then it says BCVW. Where's BCV? BCVW is a cyclic quad. Like, wow, you see, so much generosity. They didn't even need to tell us that this is a cyclic quad, because as long as you can see that points are touching the circle, like for all 4 points. As long as all 4 points are touching the circle, then it's automatically a cyclic quad. They don't have to tell you. They are just being nice here because they are feeling nice. It's nice to be nice. It's nice to be nice. It's nice to receive nice things as well. So thank you for telling us that. It says here now, CV, CV is produced to intersect the x-axis at t. Perfect. So I think we've analyzed as best as we could. And then here they told us that this is just alpha. And see, alpha is the angle of inclination. Remember, the angle of inclination is always drawn, whereas you think of this as 0. You want to think of this as 90. And then you want to think of this as 180. It's just how it is. Anyways, keeping that in mind, they said here for 5 marks. Ooh, 5 marks. Well, 5 marks is good. I mean, it's like at least. You see here, we just dealt with this gang thing for only 4 marks. So you can imagine, you see, be happy when you're offered more marks because it's like, oh, at least finally getting more for more. Because this is like getting too little for more for a lot. But let me just stop complaining because complaining is not good, guys. Don't complain. Just move on. Don't complain. Just thug it out. So here it says, yeah, I said thug it out in case that may have sounded like something else. But anyways, here it says the radius of the circle is square root of 10. Okay, radius. Oh yeah. So obviously this is square root of 10. Perfect. And then this is also square root of 10. But why am I? Yeah, well, I mean, these are equal because it's the radius, fine. But then obviously if this is square root of 10 and this is square root of 10, it means that the whole diameter is 2 square root of 10. The entire diameter, this entire line here. You see, I might as well remove this and that so we don't get confused. That let's maybe use it, put it in another color. But it's really useless because it's like, okay, duh. But like, let's put it there. We have the length of the radius, the diameter now. It says calculate the value of k if point V is to the right of point P. Yeah. Clearly show all calculations. So I think it was important for them to tell us that because you see, they're trying to give us a hint to say that the x value of V is going to be bigger than the x value of point P. So this is like a -2 or something because you see, if this is -3, this has to be bigger than that. So they want us to get this point for 5 marks. Ooh, yeah, ne? Hehe. They have started bringing that heat that has been missing. They have started. You have started, little meal. I hope, yeah, I think, okay, yeah, that hopefully came out right. But anyways, yeah. So you see, I'm even like glitching now. I'm like, hey, bro, what are they asking? How are we gonna do this? So it's fine. You wanna keep calm, obviously. Just keep calm. Don't get dribbled by questions. But the one thing I'm definitely seeing here is that, well, they've given us a distance here. Well, technically, you have the distance of PK. Oh, yeah, perfect. This is square root of 10. Oh, nice. You have the one coordinate and you have another coordinate, but then K is missing. Oh, perfect. We can actually just use the radius. You see, forget the diameter. Go away, diameter. Clearly, we don't need you. We just need the radius. Because you see, look, between P and K, V, yeah, between P and V, you see P and V, right? We know that PV is equal to that, so we can just use the distance formula to get K. Like, what a wow. Free 5 marks. Like, wow, these guys are so generous. This is so weird. They could have offered us like maybe like 6 marks here, and then here like 3 would be fine. No, here 3 is definitely fine. But I think I see what they did here, because here you are banking more for less. Here you're losing less if this question was hard. Oh, okay, these are nice people. Nice people if they want to be. If they really want to be. But anyways, let's see here. Well, what are we doing? Distance formula, right? So it's PV here. Remember your distance formula. You're just gonna have 2 big brackets with this under a square root. This is gonna be squared. This is also gonna be squared. Now what? Let me just see what. Let me just double check. The square root symbol was there. I was being paranoid now. I was like, did I put a square root symbol on that other one? I did. So anyways, here you can just put in, it doesn't matter if you put x's first here or y's afterwards, it doesn't matter. But let me just label these, you know, just so that, yeah, we can behave a bit. x1, y1, x2, y2. And then for the sake of, you know, just, you know, yeah. Yay, y, supposed to be x. No. Why am I putting a plus? Hey, excuse me, making too many dumb mistakes. All at the same time, like, wow. That moment when you just get things wrong, like, galore. Like, no, man. Anyways, PV here, let's throw in everything. PV we already have. PV is square root of 10. So you have just seen me delete stuff. Why? Because I subbed in the wrong number and carried on and bombed out. Hey, that's so sad. But anyways, we're back here to reality. So you see, yeah, don't forget that. Don't sub in the wrong things, guys. You're gonna cry. I'm not crying or anything. I'm just like, you know, I just had my crying session, so I'm definitely not crying now. But anyways, so here we want to square both sides so that we can get rid of the square root symbol. So here you can square this and you can square that, so that this cancels that, this cancels that. And then here you're going to have 10 is equal to, there you go. And yes, I literally am about to do this. You see here, don't do stuff like this, please. From here, it does not become this. It's wrong. Don't do that, please. You see, you can only distribute your exponent if these were like being pasted together. If this was like together like this and the whole thing was squared, if you had like negative 3k and you squared that, you see, if you had like negative 3k and the whole thing was squared, you see, that's the only time where you could say the negative 3 gets squared and the k gets squared. You see, that's the only time. Not if you have a minus in the middle or a plus, you see. So please don't do that. But if you were not doing that already, then perfect, man, perfect. You should pat yourself on the back because it's a big deal. Trust me, trust. So anyways, this is like 10. Let's just FOIL this out here, 2 brackets. So here, let's just simplify some more, because this is 9 plus 9, right? And we're gonna minus the 10 there, so that's gonna give us a positive 8. Fantastico. And nope, guess what? I'm not gonna use the quadratic formula. Like, what? Really? Yep. So here, 8 factors of 8, that'll give you a 6. That's just 2 and 4. And then you want to ask yourself, you see, to get a positive 6 from 4 and 2, you'd need to say 4 plus 2. There, you would have factorized. And you can only do what we've just done here as long as the coefficient of this here is a 1. So that's perfect. So here we can then say, therefore, k is equal to negative 2, or k is equal to negative 4, which is why you can already see why this was important. They said v is to the right of p. You see, v, we said it is having an x value that is bigger than negative 3. So obviously we have to disregard the negative 4 because the k cannot be the negative 4. So this is the only answer. And then that is that. You see, you get your marks and then you keep running because you ain't got time to waste. 4 marks here, they said the equation of the circle is given as this. So obviously if you want to download the PDF version of this, the link to that is in the description, in case you didn't know. Now you know, Baba. The link to this PDF file, the one that's like fully fledged, fully covered and fully done. You see all this nice color stuff here. All of the, okay, obviously all this is filled in already, but you know, because I just came from the future now and I'm telling you that all this has been filled in. So you can download the PDF and all this is there, you know. All the answers to this in nice colors is there for you. And I've just been scrolling up and down and I'm like, what? So many questions. Like, damn, man. Damn. But it's okay, man. It's okay. We ain't lazy, man. We gotta do this because, you know, we gotta do what we gotta do. But anyways, 4 marks here says, the equation of the circle is given by this. And then they say, calculate the length of BC. Huh? Which circle? Oh, the circle we're dealing with. They just gave us its equation. And you see, this equation is in a different format. So yeah, the equation of the circle is given as this. Calculate the length of BC. Okay, what's the catch with BC? Let's see, we have V now, so okay, fine. BC, oh, okay. So what we want to recognize with BC, now, don't underestimate the fact that BC are both y-intercepts, you see. The x value here is a 0, and then the x value here is also a 0. Let's label this y1 and y2. Why? Just because they are not the same, so we need a way to like distinguish the two, you see. Anyways, these are the coordinates of C and B. Okay, fine. They want us to give the length. So to get the length, we can easily just get this y here and this y there. You know, plain and simple. So the good news is, I mean, you can easily just aim to get the y-intercept or the y-intercepts of your circle because you have the equation of your circle. So in the equation of your circle, just throw 0 where x is. You see, you have an x value there. Just throw 0 in there, and then you get two y values. You see, then you get the length of BC. These guys are actually being generous here. You see. So in this equation, we don't know what x is, right? But we're gonna make x as 0. We said it, but what is going on, man? We're gonna make x as 0 because yeah, we know the x value is 0. So it's gonna be b squared here. I think it's why this is just a 4-mark question, because I mean it's so okay because it's 0 and 0 here. This is just, you can just put that into your quadratic formula. And then let's put all this into the what? Into the calculator. So into the calculator, you want to be nice and slow. Don't rush. Do not be jajarach. You will regret it. Keep calm and put the stuff in your calculator nice and slow. Okay, not too slow, because obviously, I mean, in an exam, you don't want to be like a snail or I was about to say a turtle or a tortoise, but clearly I don't know how to pronounce that word, so I literally just put myself in a really tight spot. A tortoise. What a wow, man. Like, I just discovered I cannot say tortoise or turtle. Wow, this is just crazy. Like, oh my gosh. So crazy, man. I've just made a new discovery. I cannot pronounce the T word for that animal that is very slow. I guess that's how it is from now on, man. Just gotta call it that animal that's very slow. Interesting. And I'm not even joking, like legit. The other y value, let's see here. What you get here, you get a 3, a positive 3. So these look very believable because I mean, you know, one is up, one is down. So obviously, therefore, BC, it's just 2 units. You see? And for the sake of the memo, let us write what B and C would be, because here, clearly B would be the one on top, right? So that's like 0 coordinate 5. And then C is the one at the bottom. So that's like 0 coordinate 3, you see? Because here we are seeing that, okay, this is a 3, this is a 5. So let's finesse this quickly. Okay, to be honest, I mean, like, I'm somewhat like halfway through the paper and I'm seeing this paper was okay. It was fair, you know. It was fair to a certain extent. It's not too crazy, not too simple either, but yeah, it looks like it was fair because I'm seeing these easier questions here. Analytical, obviously, analytical is the section that I always say everyone needs to bank full marks for that. Like, if you can bank at least like 80 or 90 for analytical, you're safe. Here it says k is -2. Yes, we know. They said if. No. It's not an if, Baba. It's a fact. We worked it out. You can't fool us. We're woke. So for 3 marks, they said if k is -2, calculate the size of alpha. Well, what is that thing? Get a protractor and calculate it yourself. But hey, we want those 3 marks, so hey, we'll do it for you. It's fine. So let's see. They want alpha, so we just need gradient. You know, we just need the gradient of that line here, the line that's gonna cut through this point. So we can get the gradient of VC, of which we can just use the gradient formula. You see, that's how I'm like analytical geometry, guys. It's almost sometimes, I don't want to sound condescending, but sometimes it's so simple, it's almost annoying. It's like, I'm joking, 3 marks. You're going to be annoyed by 3 marks. This nigga or this dude. Yeah, I'm black, by the way, so yeah, just put it out there just in case People are like, oh, he said the N word. I'm sorry. Guys, I'm sorry. Ekes yammer. You see what I've just said sorry in multiple languages. So I hope I'm forgiven. I'm sorry. Please forgive me. I don't know how you say please forgive me in Afrikaans. So, ish. Oopsie. What am I doing here? I'm wasting time. Here it's like native. I want the coordinates here. So let me just take them and get the gradient. Perfect. Okay, gradient is gonna be easy here. So just get that first, Don't try and do it all in one thing. It doesn't really matter. 1 and 1 minus this. 1 minus 3, that's like negative 2. Wow, I'm doing this with my head. I'm not even using a calculator. Such bravery, or tempting the universe, whatever you want to call it. 1 minus this is negative that. This minus 0 is a negative 2. So that's a positive 1. Let's see if this gradient is like a positive number. Yeah, this does look like it's a positive gradient, obviously. So this is like a positive 1. Now here we can just use that to get tan alpha. So what you do, shift tan alpha. That's going to give you a 45 degrees because the NBT paper will remind you that you need to know this easy stuff, because you see, yeah, I was about to off ramp and talk about the NBT, because you see, I signed up to write the NBT so that I can like get a good mark and show that the NBT course actually works, because like you see, while preparing for the NBT test, or the NBT rather, I'm going to be using the course that I created. Well, I'm only writing the thing to show that the boy is capable of creating an NBT course. So the NBT course is worth taking, because the boy would have proven that the boy can get good marks for the NBT math test. So that's why the boy signed up to write the NBT, and the boy will make his results public. Hashtag I'm the boy. So when I say the boy, I will be referring to myself so that you don't get confused. But I'm assuming you knew that already, because you're smart, and I'm busy here just talking. I'm not even thinking what's going on. 2 marks. 2 marks. They want us to get VWB. VWB. What? VW. But anyways, for 2 marks they said, where's VWB now? V, you see, too much math, guys. It's literally making me go mad. Like legit, I can feel my brain just wanting to just be dumb. But anyways, VWB here, they want you to get that angle. You want this angle? Can you even afford this angle? How many marks are you offering? Let's see. 3, 2. Yeah, let me not even lie, né? I'm not even gonna cap on this one. If this was an exam, just for 2 marks, just looking at this, I think I would have probably, what would I have done? I think I would have probably maybe just moved on and came back or something. But it doesn't look too bad, because the one thing I'm seeing here is VWB may be this angle. But then let's try not to focus too much on that angle, because it's a cyclic quad after all, Remember, cyclic quads, you need to think of things like exterior angles of a cyclic quad and all that shandies, of which I think that can really help you. Because, you see this question, you need to finesse this thing. It's out of 2 only, so you need to think outside the box. And when I say thinking outside the box, what I mean is, you see here we have an exterior angle. This is an interior angle of a cyclic quad. This angle there is equal to this angle over there. Why? Because of exterior angles of an exterior angle of a cyclic quad is equal to the opposite interior angle. So let me actually just use a bright color to highlight that, because you see this pink is not doing the things, So this angle over here is equal to that angle over there, exterior angle of a cyclic quad. Now, all we want to do is, we can easily just get this angle here. Now, you may be asking yourself, how do we get that angle, bro? Like, how? Well, you finesse the question, you finesse it. What I mean is, what you want to remember, if you can recall from like the analytical geometry course, what we mentioned was that here, this point here, you can literally for yourself think of a horizontal line that is parallel to the x-axis. This horizontal line that is parallel to the x-axis. If you can just think of that line, right? What you already know is that if this is alpha, this is also equal to alpha, because these are corresponding angles. So you know that this is 45 degrees, you see. Now if this tiny portion is 45, this tiny portion has to be 45, because the whole thing there is a 90-degree angle. You see all this stuff showcased within the course. So this is 90, this is 90, and we said you can imagine this purple line for yourself. It's not like you making up your own stuff. No, it's a fact, Baba. It's a fact. If there's a horizontal line over here, this angle would be 45, meaning it would be the same as that one, meaning that this is also 45, and then automatically you have your 45. You see, that's why they're making this a 2-mark question. So for these 2 marks, we first need to tell them what we know. Tell them that this is equal to that first. Just start there. So this is B V A. What now? What can you call this angle here? That's kind of scary, because it's like, oh man, we don't have a name for it. Or do we have a name for it? Let's see what kind of letters we have here. We have B, V, W, what. Where's T? T is there, and then P is there. Yeah, so I think naming this angle here is going to be a bit of an issue. So does that mean we have to think of like another way to like show that this is 45? Honestly speaking, no, I don't think so. I feel like I may feel like I think I am maybe being a bit arrogant, but it's just for 2 marks. If push does come to shove, you can just drop equal to 45 there. If you're lucky, they'll give you a full 2 marks, but if you're not, they'll just give you 1. So in order to get all the marks, yeah, we need to show them that B, C, yeah, this angle here is equal to 45 because it is equal to this other angle that's equal to 45. Yeah, so that's kind of, this is one of those things where you're like, but then how do you get the 2 marks without just saying your answer? It's quite an interesting phenomena. But then here you do have your sketch, right? And I mean, this will probably not be on your answer sheet. So yeah, we need to think outside the box just a little bit, but not be too aggressive about it. So with what we've just showcased now, I think we can just think of that as like one train of thought. Another one, we could just think to ourselves, I mean, this is 45, right? We know this is 45, so that's fine. We know that this is 90, so that's fine. Let me just remove this other side here. This is 45 over here. This is 90 over there. So we can get that angle there, you see? And then after getting this angle here, we can easily get this angle over here because of angles on a straight line. And then eventually see opposite angles of a cyclic quad add up to 180. You would still be able to show that this is 45. So I think this one is traceable. So let's use that one. Let's just show them that TCO is equal to 45, because you see, it's going to be 180 minus this minus that. So yeah. Oh, and then we can just say exterior angle of a cyclic quad from here to there. Hey, let's forget this one. You see, it's along the right, that one. So let's just show them that TCO is 45 because of interior angles of a triangle. And then we just show them that this is 45 as well. I think you spotted that, which is dope. I was still thinking, you know, but we've got it now. So let's make this the same color actually. Whew, let's write that down. What did we say here? TCO. We've said it's equal to 45, and then here we're going to say TCO is equal to VWB because that's an exterior angle of a cyclic quad. So obviously, with that being said, we can then say VWB is equal to 45, you see. So all this is all nice and dandy. It's also, I think, it also goes to prove that, you see, doing this whole dotted line thing is a viable option if push really does come to shove. So let's just remove that because, hey, we don't need that no more. But it helped to a certain extent, you know, got us thinking. So let me actually maybe highlight the yellow parts for the memo. And then let's move on. Let's keep moving forward, Baba. Johnny Walker. But anyways, 4.1.1 for 2 marks only. It says a new circle. Ooh, we're talking about a new circle now. Like, why so many circles? What's up with math and circles? Like, I don't get it. Like, so many shapes in the world and you focus on the circle. Hey, yeah, ne? 2 marks. They say the new circle is obtained when the given circle is reflected about the line y is equal to 1. Then it says determine the coordinates of Q, the center of the new circle. Okay, so this question should not be too bad. We need to just be able to visualize it, which is why this format that we use for the course platform works, because you being able to see a line that has been reflected about, you being able to see a circle that has been reflected about the line y is equal to 1, that's going to be super easy to do with what we are using here. Because here, look, if I draw this circle, you see that? It fixed it for me so that I can explain better. So you see this circle over here, right? What they are saying is that this circle is reflected about the line y is equal to x. Now you may be thinking to yourself, where's the line y is equal to x? Or let me make this a bit smaller so that it matches exactly what we're given. Boom, exactly, because this is going to help us explain. So the line y is equal to x, no, y is equal to 1. Let's think of the line y is equal to 1. The line y is equal to 1, which line is it? It's this line over here. You see where vk is? There's a 1 over there. The y value here is a 1. So the line y is equal to 1 is this line over here. That one. No. Don't be dumb. Come back, please. This is the line y is equal to 1. Now, this line here, they say they reflected this circle about this line here. And then once they've done that, they want us to give the equation of the new circle. So obviously, when this circle has been reflected about the line y is equal to 1, our circle here, we're just going to have another circle down here. You see, like that. That's the scenario that they're talking about, of which our original circle has a center P. Our new circle, they are saying that its new center is going to be referred to as Q. And then we need to find Q, you see. They want us to find Q. So how many marks are they giving us? You see, that's why they're only giving us 2 marks, because if in terms of us finding the center, you know, it's just a reflection of the original thing, you know. So if you think of it, you see, from P, if you think of the new center, well, the new center, let's actually be more accurate. You see, the new center, technically, this x value here is going to be exactly the same. My circle should actually move a bit. There we go. You see, it's even aligning it for me so that I can explain better. Like, this thing is so nice. Like, thank you so much. But we actually need to move it a bit more to the thing. Do we? Maybe just a little bit. Wait. Yeah, this is perfect. You see, it's telling me that the centers of my 2 circles are the same. So we can explain better now, you see. So if you look, the x value here, right? You see, it's going to be exactly the same as the x value of the new center. So the new center, wherever it will be, we can already see the x values are going to be exactly the same. So if this x value is a -3, the one down here is going to be a -3 as well. So let's do that first. Now if you compare the y values, comparing the y values, just compare the distances between the y value. You see, if the y value from here, we know that the y value from here going to your thingy. Yeah, I think with the y value, this is where we're going to need to explain nicely, because you see, we need to think of the radius of the circle. Because look, well, not really actually. I think this one we just need to finesse it nicely. Just we need to think logically here. So for us to get the x value of our center, what you want to think to yourself is, you see, here they're telling us that the y value here, if we want to get the y value, we know that the y value up here is a 4, meaning the distance from here going all the way downwards, that's a 4, you see. So it's like this going downwards all the way until there. That's like 4 units in total. You see, that's like 4 units in total. Now, obviously, instead of you worrying about those 4 units in total, what you can think to yourself is, instead of thinking of that whole 4 here, all you can think to yourself is, you see, the line of reflection is what you should be worrying about. You see, your line of reflection here, the line of reflection here is just y is equal to 1. So you can just think to yourself, the distance from 4 to our line of reflection, that's like 3 units, you see. So obviously from the center here going to our line of reflection, this should also be 3 units, you see. So now you can just think to yourself, from positive 1 here going downwards, you see, this should be 3 units. This is not the radius, you see. Remember here, these circles here, they don't touch each other here, you know, they like cross each other. So that tiny space there should make you realize that from here, which is the line of reflection, going straight down to the center, that should be the same distance as from here going there, you see. So we said if this is the line y is equal to 4 and the y value here, this is the line y is equal to 1 and the y value here is a 4, it means that the distance between the line of reflection and this point, that's just 3 units, you see. So on the other side, this should also just be 3 units. So from 1, if you go 3 units downwards, this will land you at negative 2, you see. So that's how we know that the y value here is just a negative 2. So you go down YISO and you put your negative 2 there, and then they'll give you your marks, you see. So here, that's the analogy we used there. Negative 3, coordinate negative 2. And for the sake of the memo, I will leave this circle here just to showcase, you know, that it was going down in the video. It was going down. It was going all the way down. So I guess this question was okay. It was okay. It was okay. Nothing crazy. Not too easy. No, it was not easy. It was not too difficult either. So they said here the equation of the new circle. We need to determine the equation of the new circle in this format. Okay. Well, we have the center already, and the new circle will have the same radius because it's just a reflection. You see, it has the same everything. It's just a reflection of the thing. It's like when you look at yourself in the mirror, you're going to see exactly what you are, you know. Unless your mirror is dirty, then who knows what you're going to see. So anyways, in this case, our radius, we already know, they told us right in the beginning, it is square root of 10. The center we have, so automatically, remember, with your center, always take the opposite if you're going to put a value for a and b. So if the center is actually, if the x value is a negative 3, your a value is actually a 3. If the y value is a negative 2, the b value is actually a positive 2, you see. That's all stuff we even showcased in like the analytical geometry playlist on the main channel. Hashtag Bright Young Brains. You see, Bright Young Brains, that's the main channel. And then this is the course platform. And then this is the math page on IG. And then this is my IG page, the main IG page where I like, you know, post updates and all that shandies. And yeah, man, hit me up. What's up? So anyways, where was I? Yeah, here we can just put A, B, and R. So here we can say, there you go. Now putting square root of 10 squared, that's so cringe worthy. Like, damn, bro, just get rid of the square root and the square. Yeah, obviously square root of 10 squared is just going to give you a 10. But I mean, for the sake of the way they want, hey, nah, I always just leave it like this, you know. I'll be like, hey, it's fine. I'll say we should leave it like this. So, hey, there you go. you can deal with the square root and the square on your own. But obviously simplified, those would just cancel out. So I just leave it like that because I got marks for that anyway. So it's cool. So here it says the equations of the lines. The equations, we should determine equations of the lines drawn parallel to the y-axis and passing through the points of intersection of the two circles. Let's calm down. Let's see what they want here. They said we should determine equations. You see, because the whole thing is here. You see, determine the equations of the lines drawn parallel to the y-axis and passing through the points of intersection of the two circles. Oh, what a wow. These people are so demanding. It's like, yeah, okay. I feel like this section of analytical geometry, yeah, I won't sugarcoat it, ne? These last few questions are lit. Like, especially this. Okay, this one is not lit. Okay, and like, this one also is not, okay, okay, no, let me not, okay, yeah, I don't even know what to say. I don't even know what to say. Is it hard, difficult? Is it easy? Is it normal? Is it standard? It's just, hey, it's a question paper. It's an exam, this one. It's an exam. So the points of intersection, clearly it's like this point here and this point over there. That's the point of intersection of the what? Of the what? Well, yeah, let me just adjust this a little bit. Whew, yeah, I wanted to make this super perfect for this question because you see, these circles have to touch at the line of reflection. So, with everything that they have told us here, well, what have they told us? They said we need the equations. Did they say equations? Let's see if there's a plural there. Oh, yes, there is. Iso, plural. That's the only thing I remember from English, plurals. And what? Yeah, that's it, bro. Just plurals. So here we have, yeah, they say we should get the equations of the lines drawn parallel to the x-axis and passing through the points of intersections. So all we need is, all you want to remember is the lines that they're talking about, ne? Is just two lines. There's one here. Those two lines. I want you to give equations for those two lines. Now, all you need is the point of intersection. You see, you need to know what is this x value, and you need to know what is that x value. You see, because they said you need to find their equations. And these lines, you see, that they are definitely parallel to the y-axis. So the good news here is this one we already know. This one is just going to be determined by the x value of v, you see, of which the x value of v, we worked it out to be like a -2 there, you see. So one of your equations, you know that it's just going to be x is equal to -2, because remember, any vertical line, we know that its equation will always be determined by whatever x value it cuts. So one of the lines, we're going to say y is equal to -2. The other one, yeah, the other one is like, hey, the other one we need to finesse it, you see. Yeah, okay, yeah, this question was quite intricate. So here, the other one, just think of how, if this is the middle, you know, this is like an x value of like -3. So this x value here is a -3, right? But then this x value is like a -2. So automatically you can see that the distance apart there, that's just like 1 unit, you see. Because this x value here, you can see that's like a -2. In the middle here, you can see that, okay, this is just a coincidence. In the middle here, that's like a -3. So you see the distance apart here should be the same on this side as well, you see. So the x value that this cuts is like a -4, because the distance from the center here to this is like 1 unit. So the distance from here going to the other side should also be 1 unit, you see. You want to think using that logic. So here you're just going to say y is equal to -4. And you may be thinking, are you guessing? Are you assuming? No. We're not assuming, we're not guessing, we're just using pure logic. You see, this is in the middle. So obviously, if this is 1 unit to the left, it should be 1 unit to the right. Whew. Okay, yeah, that question. Yeah, okay, yeah, this section, yeah, this segment of the analytical geometry, I don't wanna lie, it was hot. But anyways, let's move on to question number 5 now. Whew, halfway through the paper. So if you're like thugging it out as well, then let's go, man. Let's go. Halfway through the paper. Let's keep going. Let's keep going, man. Let's keep putting in the work. So for 5 marks, right? Let's see here. They said simplify the expression to a single trigonometric term. So questions like these, you know, they are nice. They are just so nice. So anyways, what we have here? Well, the issue first is that anything with a negative angle will always come out with a negative outside unless it's cos. You see, if you're dealing with sine or cos or tan, anytime you have a negative inside here, you see, the negative always goes out, except for cos. You see, for cos, we already know that this is just the same as cos x. You see, that's the only one where the negative here does not really change anything. But then for the others, the negative goes outside. You see, so here we already know that we need to remember that it's just going to turn into this. Now, we have also stated within the trigonometry playlist on the main channel that when you look at stuff like this, right, always flip it around. Because the moment you do that, now you can use your what you may call your cast diagram to help you. Because using your cast diagram, what you can already see is that, you see, this is 0 and then 180. Hey, 090, bro. What the hell? How can you put 180 there? Huh? Bro, what the hell is that? Yeah, this is 180 here, 270 here, and then back here is like 360. So the issue is, you see, when you're dealing with negative angles, you see, instead of you going anti-clockwise, you're dealing with the negative. It says go clockwise first. And then you see, you plus, you'll be going anti-clockwise. So what I mean is 180 plus means you're going to go, instead of you going this side, you see, you go the other side first. You see, 180, negative 180 means you go negative 180. And then the plusing the x there means you now go back and then you end up in this quadrant, of which in this quadrant, if you look nicely, according to your cast diagram, you see CAST. This quadrant here, only 10 is a positive. So automatically you know that this thing here should give you negative sine x. Perfect. You see, we've dealt with this, we've dealt with that, because that's the only things we really need to deal with here. So let's get our marks. So here we said we can just turn it to this. And then this here we say this becomes a negative. Now obviously this negative times this, everything here, you see there's a negative times a negative. So meaning everything will become a positive. Like that, you see. And then obviously this we have to put it with the denominator, which is cos x. The issue is these others here, you have to put them over 1. You see, so that things can make sense. Because you see, you want to recognize that the top you can multiply it together. And then clearly, as this can cancel this. This can cancel that. Like, you could have just said that, bro. What is this is canceling this? What are you trying to do? Just say it like it is, man. So yeah, sine squared x is your single trigonometric term. Therefore, you'll get 5 free marks and you keep moving forward, okay? You don't look back. So for 2 more marks here, they said cos 35 is m. So here, this was like so basic. Such nice people. So they say cos 35 is m. Here, if they say without using a calculator, the moment you read these questions, you don't even have to worry about reading the rest. The moment they say without using a calculator, I mean, these, you see, these things, you see, you should already know that they're going to ask you this. That's the thing with exams, especially like prelims and finals. You already know exactly what kind of questions they ask. So always know that, okay, this question, all I do is, they said without using a calculator, I determine the value of each of the following in terms of m. for 2 marks. So this here, you want to recognize that they've told you that it is equal to m. So all it means is the m, you put it over a 1 first. So that you draw a sketch, just a random right-angled triangle. When I say a random right-angled triangle, I mean exactly that. It's just a random right-angled triangle. It can face up, down, it doesn't even matter. Because here they have not given you any restrictions or anything like that. So just draw a random right-angled triangle, as random can be. And then with that random right-angled triangle, let me not be jajarach now. Let me just chill. So this, move it to the corner. This right-angled triangle here, you want to map out the information that they've given you. Like you see, cos 35. So meaning here you put a 35, you can put it anywhere you like. This is saying adjacent over hypotenuse. You see, ADJ over hypotenuse. There you go. You see, adjacent is m, hypotenuse is 1. And then obviously you need to get this over there. So getting this over there, you can just use your calculator. Oh, no. Yes, your no. Calculator. I meant Pythagoras theorem. Here. I'm so used to the calculator. I'm thinking of that NBT. I'm like, calculator. No calculator. But anyways, solving for x here is going to be simple. Because you see, you need a value for this here. So here it's 1 squared. There you go. And then obviously 1 squared is just a 1. And then, I mean, we all know that you're just going to square it both sides. There you go. Perfecto. Now we can answer our question. But you see here, you can even put in a value there. Because 90 minus 35 minus 35. Let's see what that is. 180 minus 90 minus 35 to get that angle there. Because everything in the triangle adds up to 180. So if you remove the 35 and the 90 over there, you're getting this angle to be 55. Perfect. That may or may not help us. We don't know yet, but it looks like this is, it looks like it might help us. But for now, you see here, they want you to, for 2 marks only, they want you to get this. Now, questions like these, always think of special angles, because I mean, you want to think to yourself, which special angle is this close to? It's close to 180. And then you think further and think to yourself, 180 plus this here gives you that value, you see, so you can start there. And then obviously if you use the reduction formula, 180 plus, always draw out the cast diagram. Don't think you're too special to draw out the cast diagram. Like, hey, you'll get hurt, you'll cry. But to avoid pain, just draw it. You see, 180 and then plus. So only 10 is in that quadrant. Only 10 is positive in this quadrant. So this has to be a negative cos 35. And then obviously negative cos 35 is just negative m, because this is cos 35. So negative that is just negative m over there. You see, because where cos 35 is, you're just going to drop an m there. And then you see it has a negative. And then you keep on moving forward. You don't look back. You get these next 3 marks here. They want sine 30 and sine 20 for 3 marks. So obviously, again, you see, if you have conditioned your brain to like see these kinds of questions, what you're already seeing here is that 55 and 35, that's going to give us a 20. So you start there, you see. Sine 55 minus 35. This is what can give us a sine 20. You see, so we already know that sine 20 is equal to this thing here. And then we just break this down using our what you call, our what? What do you use, bruh? We use our compound angles. Yes. Our compound angles. That's what we use. So with our compound angles, what we know that this is just going to be sine and then cos. If this is a minus, this is a minus. You supposed to be 35, boss. There you go. Before I carry on, now I'm not going to be too special. I'm going to double check with the formula sheet quickly, so that I make sure I did not make a mistake, because I'm afraid of mistakes. Okay, I'm not afraid of mistakes, to be honest. I'm not afraid of mistakes. I just don't like silly mistakes, especially if they can be avoided. You know, if they can be avoided, yes, I said that. on purpose because I want to. If they can be avoided, then you need to avoid them. Yeah, looks like it checks out. It checks out on our formula sheet because, you know, sometimes don't be too confident. What am I saying? Don't be too confident. Well, I mean, your level of confidence should be high, né? But then not to a point where you're arrogant, you know. So like just double check stuff if you feel like you need to, so that you don't like end up losing marks just for like the silliest of things, you know. So let's see here. Let's use our sketch. Sine 55, that's like opposite over hypotenuse. Cos 35, we know that that's just the m. And don't mind the brackets. They're just, you know, just for aesthetics, you know. Aesthetics. It is what it is, man. Just for aesthetics. So here, this is just the m. And then this is cos 55. Cos 55 here. So it's like adjacent over hypotenuse. And then here, sine 35, that's like opposite over hypotenuse. There you go. So here, you can just simplify one line. You don't have to simplify crazily. That's not a word, but hey, we're feeling funky right now, so we're gonna be saying anything and everything. There you go. You can just leave it like this. No need to simplify further because why? Like, why? You know, it's just 3 marks. This is absolutely good enough. Trust. So anyways, let's move on to the next 4-mark question here. They want the general solution. Now, I mean, if you're looking deep into this question, I mean, look at it. It's screaming compound angles. It's like it can't even help it. The only issue here is, you see, it's cos, and sine. So obviously, if it's a 4x here, these two, they're just swapped around, but it doesn't matter. So you don't even need to like like what you call rewrite it or whatever. This is just going to be 4x minus x because of our compound angles. Yep, because you see cos, and then there's sine and sine. Here there's 4x, here there's x, here there's 4x, and there's x. These are just swapped around, you see, because this should be there, this should be there. But because you're multiplying, you can write them whichever way you want. Here, if you simplify, this is just going to be this. And they said we want the general solution. So meaning from here, you get a reference angle. Meaning, remember when you get a reference angle, you only use this and this number here. You don't use the negative sign. Although negative, you leave it. You only use it to choose quadrants and stuff. So your reference angle here, let's get it from this. That's like 45.57. 45.57 is our reference angle. Yeah, that seems okay. So your reference angle over there. Now you use your sign to pick a quadrant. You see this thing here, you use it to pick a quadrant. So the quadrant that we want to work with is where cos is a negative, which is going to be this quadrant and this quadrant. You see, this is the quadrant 180 minus a reference angle, and then this is the quadrant 180 plus a reference angle. So let's just use those two quadrants and get our answers, and we get what? We get marks, because that's what we want. That's all. What do you think an exam is for? Hey? Marks, Baba. We want the marks. So let's do that. Let's see here. In the second quadrant, yep. In the second quadrant, let's see here. We are going to need to say, well, we need to carry on with the 3x now. 3x in the second quadrant is going to be equal to 180 minus the reference angle plus k360. K is element of integers. And then here we said, let's put this in the calculator and then divide by 3 afterwards, because when we divide by 3, everything has to be divided by 3. So this 180 minus this here, that's like 134 point something, 134.43. And then now we can divide by 3. Everything gets divided by 3. This is going to give us 44.81. Yeah, 44.81 does seem believable, to be honest. Obviously, with questions like these, right, you do want to double check maybe like your steps, see if you didn't make like a error with the signs and stuff like that, because yeah, man, you can easily get yourself into a bit of trouble if you don't check nicely. So I'm literally just checking here as well. Yep, looks fine, looks fine. Nothing crazy, nothing major here, nothing to look at over here. So the next one, yeah, we need to work with the other quadrant, and I just gave myself so little space. Okay, I didn't give myself a little space, I just wrote so big, like, yo. So from here, let's work with the other quadrant. Let's use a bright green. Where is thy green? This green here. Yeah, this green, guys. Yeah, it's like sports car green, this one. Anyways, the third quadrant, what you're gonna get, it's 3x is equal to this plus the reference angle, you see. There we go. Now here, carrying on, let's just, yeah, there's no need to talk anymore. We can just finish this one legit. There we go, there we go, there we go, there we go, there we go. Okay, that's that. So obviously cases where you use the K method, you can definitely check that out on like the trigonometry course and stuff like that. For 4 marks here, they said prove the identity. So I mean, this one also, okay, no, okay, this one, proving this identity is not bad at all, because this is one of those identities where they have like an inferiority complex, you know. They look like they are hard or difficult, but they actually, you know, punchunanas, you know, just nice and tiny and small. But anyways, so with this one, for example, you see when you're looking at this, right, don't panic. For example, you see here, this should remind you of like double angles. You see, this is the double angle, of course, so we should be thinking of double angles. The other issue here is, you see where there's fuel, there's definitely el fuego, you know, el fuego, that's fire, you know, fire. So what I mean is, you see here there's a 4x, you should take note of that. And then there's a 2x, yeah, there's a 2x here, whereas this side there's no 2x. Or rather, look at it this way. You see, there are two sides to this thing. You have sine 4x and then cos 4x over there. You see? So obviously, I mean, this looks like it can go with the rest of this. Because, I mean, if you think of your double angles, or rather compound angles, you see, this cos 2x here. On the side, for there to be a match, you can think of this as like sine 2x. Because you see the green part, that's just the double angle of sine there. So let's start there. You see, let's start there. Let's start there. Do you have money? Homework. Let's see here. So you see, these two sine x cos x, this, we know that we're going to deal with that just now. This 2 sine x cos x can be written as sine 2x. You see, there you go, there you go. And the bottom, what you do with the bottom now? Or the bottom, you leave it for now. You leave it for now, brother. Tan 2x, perfect. You see, and now the top, you can just simplify that using your compound angles. Of which, using your compound angles, what you can already see is that, you see, it's sine and cos, cos and sine. So it means you're going to end up with a sine where it's this angle minus that one, because there's a minus here. Anyways, so from here, now what? So 4x minus the 2x, that's going to give you sine 2x. And then you can already see here where there's fuel, there's definitely what? Say it with me now. El fuego. Anyway, so here you want to write this like this. You want to write the division line as this. You see, like that. And of which on the course platform, we showcase things like this to say it's going to help you simplify better, you know. so that you don't make silly mistakes or anything like that. So from there, you can tip and multiply now. And then what you know is the top stuff is at the top. These two are at the top, these two are at the bottom, you see. So 1 here cancels 1 there, which is cos 2x, which is just this because of your double angles. Well, therefore, the left-hand side is equal to the right-hand side. Nothing crazy here. Nothing major, nothing major, nothing major. Yeah, it was okay. It was an okay format question here. Not too crazy. For question number 6, we have a trig question. Woo, it's a 6 mark. Wait, forget the 6 mark allocation. Let's see what the question says. We have, what do we have over here? It's a 6 mark question, right? It says, in the diagram below, the graphs of f of x and g of x are drawn for the interval x is the element of negative 180 all the way to positive 180. And then it says A and B are 2 points of intersection. Oh yeah, so this one I kind of read it like a novel, which is terrible. In the diagram below, 2 graphs. Okay, f of x. Okay, it's a, what kind of a graph it is? It's a cos graph. And you see this 2x here is giving you the idea that your frequencies are 2. So let's move on because this is the amplitude. So yeah, a lot of this stuff, you know, trust me, go through the trig course. You will get all this information with regards to like the theory and all that you need to know before you tackle exams. So all this being said, they just said here, calculate without using a calculator, or without using a calculator rather, determine the values of x for which cos 2x is equal to negative sine x. That's technically them asking us where do the 2 graphs meet. You see, they're literally just asking for A and B. They could have just said get A and B, or not, because there's another one here. Ooh, yeah, apapalele. Yep. There are 3 places where they meet, 1, 2, and 3 over there. So yeah, we need to be careful. Anyways, with all this being said, let's just work this out. You know, plenty of space over here. Whew. So what you got? Well, here the task would be for you to get 1 trig ratio. So the easiest way is to just change this into something that is sine, of which you can do that using our double angle. Take everything to one side. There you go. Well, there you go. Okay, never mind. This here, you want to think of it as a quadratic equation, you see, in the sense that A is just a 2, B is just a -1, C is also just a -1, you see. And then the sine x here should be in the place of x when you think of the quadratic formula. So here you're going to say sine x like that, you see, of course. So now you just want to throw in values into this. There we go. Let's put all this into the calculator and see what the calculator gives us over there. So all this into the calculator, we are getting -1/2 and 1. +1, please. There we go. So obviously these two, we need to use them further for us to get the rest of our answers. I think it's time for us to change colors. Like, yo, we've been using them same colors, bruh. Oh, wow. These can go for a while. But these are class. No, let's replace them with these. Yeah, these are boring now. Let's replace them with these. Done. Let's go. Let's test out our new merch. Let's see here. Nah, that was well. What did I just do now? I replaced it with these ones. Come on, bro. Like, you're joking. But let's not waste people's time. Let's see here. What you got now? So we have to carry on from these two, right? You see? So that being said, let's see here. Let's start off with this one. So sine x is equal to 1. You get a reference angle 90 degrees. And then we want to work with where sine is a positive, which is obviously the first quadrant Obviously in the first quadrant you just carry on with x. And then what you need to do, you need to work with the second quadrant, of which in the second quadrant we know it's just 180 minus the reference angle. You're gonna get the same thing. Like, oh my goodness, bro, like wow. So here I don't think you really need to carry on here because it's gonna give you the exact same thing. So we can just move on to the next portion here, which is this thing, you see. Why am I wasting space like this, huh, bro? So when you get a reference angle here, remember, be careful. Don't use the negative thingy there. It'll hurt you. So here, reference angle is just a 30. It's just a 30. So obviously we need to work with quadrants where this is a negative. Now the quadrant where sign is a negative, that's going to be the third quadrant to begin with. So this is going to give it 210, which is not valid because you see, it's outside the given domain. So you cancel it. You see here, look. Kekiso, you see? They say between 180 and negative 180. So this answer here is not valid. So you cancel it and then you get other options. So other options would be coming from quadrant number 4. That's why it's also negative. 360 degrees minus the reference angle. This is also not valid, so you cancel it. So you obviously may be asking yourself, but then how are we going to get this answer here? How are we going to get this one? Because it's a point where they meet. That's where the k value comes into play, because you only use your value of k if you have been given a domain to work with and you have not yet gotten all the solutions in that domain. So because those graphs meet at 3 points, so for you to find the other point where they meet, right, we can just use the k. Now we need to make use of k, and now we need to use those other blue colors that we were crying for. And I look at them and I'm like, okay, they're not that special. This is like, you know, wedding purple or like baby shower purple. You see this purple in so many baby showers or like weddings and stuff. You see, that's why I call it baby shower purple or like wedding purple. But anyways, that's not important. So yeah, where k is in your up here, you see where we have here this k, all you want to do for yourself is you want to think of throwing in values for k here and see if you are going to get solutions that are within this domain over there, in the sense that you want to think to yourself, let's say if k was like a negative. If k was a negative, that's not going to help. Like a -1, it would not give you a solution within this domain. If k was like a -2 or 1 or 0, here you can't do anything with k. So you try out, let's say this one here. So even though we are not going to consider 210, what we need to think to ourselves is that, let's see here, if you put a k as -1 here, you're going to have -360 plus 210. -360 plus 210 is going to give you -150, which makes perfect sense because you see, it looks as though this one is the one that's -150. And then obviously for this one, if k was a 0 here, you know, x would be a 90. So x is equal to 90 is also our solution. And if you look, this definitely looks like it's going to be a 90. See, because there's 180 here, there's 0 there. So there goes the 90. Perfect. Now, obviously, we need a value for this over there. To get that, you still just use your k. Let's see, if k was what? Hey, yeah, this one doesn't look like this one is going to give us what we want. Or does it? Or does it look like, okay, what about this one? Plus k 360. Yeah, this one would have carried, if we had carried on with this. Let's put there. All we have to do here is we have to think of k here can be a -1. If k was a -1 there, that would work out, because in terms of integer values that you'll be choosing, right, it's any integer value like -1, -2, 0, 1, 2, 3, or anything like that. And again, you see, if these kinds of stuff are still troubling you, then trust me, you know, I'm not trying to just plug myself or whatever. I'm really just trying to give you the idea that if math is still a struggle, then you really need to enroll yourself into the course platform, because you will get help, I promise. So this is like -30, and then well, we have already used k, or we have to state we're about to use k here. So see, I'm getting distracted here. You see, before you use k, we can tell them we're about to use k. So here, let k equal to -1, because if you throw a -1 there, you're going to have this here, and then carrying on from there, you're going to have x is equal to 30. So let's highlight our answers, because there's 3 of them, you see. And did I get rid of that other red and purple thingy? I did. Wow, I want it back because I wanted something super bright. So this is valid. We want a bright red winner. Okay, that's not a red, this is reddish. So yeah, this is an answer, this is an answer, and then this is an answer. You see, let's just drop the dotted lines as well, you know, just so that it doesn't feel left out. Whew, this question was hard. Okay, no, it wasn't that hard. It was just long, and it looks cramped because I didn't give myself enough space. Like, oopsie. Here it says, use the graphs above to answer the following questions. For 2 marks, it says, how many degrees apart are the points A and B? Wow, such free marks. Thank you so much, guys. Thank you so much. So degrees apart, I mean, if the you want to think to yourself, from here to 0, that's like 150 degrees. From here to there, that's like 30, you see. So you're going to say 150 minus the 30. And then they'll give you 2 marks, you see. 150 minus 30 equals what? 120 degrees apart. Apart. Perfect. 120 degrees apart. Nothing crazy there. I feel like they just wanted to give us marks here. Like, hey, okay, it's fine. We'll take it. Because you're dealing with distance, you see. Remember, distance, you always take it as a positive value, because the distance from here to there is 150 units. The distance from here to there is 30 units, you see. So 150 units minus 30 units gives you that distance in the middle there. Whew! Yeah, so much space just for this question, bro. Like, you could have literally just, my guy. For 2 marks here, they said, for which values of x in the given interval will this occur? So if you can recall, on the main channel, right, there's a playlist on inequalities, of which that playlist absolutely goes through questions like these to the point where it's like, oh, what a wow. So anyways, here it says, for which values of x will in the given interval. The given interval, we already know it's between -180 and +180. So that given interval, they said we should work out where the gradient of f times the gradient of g will be a positive number. You see, all this stuff, if you don't understand that, will give you a quick idea as to what's happening here. You see this, remember, this is the first derivative, this is the first derivative. It refers to gradient. Now, for a question like this, what you just need to consider is that for 2 marks here, they're saying, where is this times this bigger than 0? To answer a question like this, you need to remember that this expression will only be a positive number. You see, that's what this bigger than 0 means. It's asking you, where will this expression be a positive value? So this will only be a positive value if at least one of them is positive, you see. Or rather, no. This will only be positive if both of them have the same sign. You see, it'll be positive if both are negatives or if both are pluses. You see, we have to look for cases where the gradient of f is a positive while the gradient of g is also a positive, and then cases where the gradient of f is negative while the gradient of g is a negative. Now you may be asking yourself, how do we find out the gradient? All you need is to find out whether the gradient will be a plus or a minus. You see, you don't need the actual values. You just need to know, will the gradient at a certain point be a plus, or will the gradient at a certain point be a negative? So keeping that train of thought, right? What we need to think to yourself is, okay, if you're looking at two graphs, right, always remember that if you want to find out if a point has a positive gradient or a negative gradient, it's simple. Just as we have already stated within the playlists, all you want to think to yourself is, if you're riding a bicycle, let's look at F first. If you're riding a bicycle, right, every time that you're riding down, you have to remember that every time that you're riding down, the gradient there is a negative, you see. So here, you're riding down, riding down, riding down. Up until this point, you see you had negative gradients, you see. And then from here all the way until up there, you see you had positive gradients. And then from here going down, you have negative gradients. And then from here going up, you have positive gradients. You see, anytime you're going down, that's negative. Anytime you're going up, that's positive. So with this one, same thing. Every time you're going up, you see positive gradient until this point. And then you start coming down until there. And then here you start going up again. You see. So let's just do something simple. Let's just color code our image here. We're going to color code it in blue and orange. Let's do both graphs. So both graphs here, we're going to color code them in the sense that the parts that have negative gradients, we're going to put them with orange. So here, let's start with F. Here there's a negative gradient. You see, here it's positive. So let's leave it for now. And here there's a negative gradient. And then this is positive. Fine. For our graph of G, let's do the negative gradient portions. You see, for negative gradient, it's only from here until there. There we go. Now let's deal with the positive gradients for both graphs. So for both graphs, positive gradients, we have positive gradients there for the graph of G and over there. You see, the graph of F, positive gradients over there. Perfect. Now we said our expression will only be positive if both gradients are positives at the same x intervals, and then where both gradients are positives at the same x intervals. You see, both gradients have to be negatives at the same x intervals. Both gradients have to be positive at the same x intervals. So if you look at your image here, let us be like a surgeon here. You see, you want to look for cases where if you're looking from left to right, you have the same scenario playing out. Like they both have to be having like positive gradients or stuff like that. Like you just look for cases where you see your colors are matching. Let's look from the left. You see, from the left, you see this one has a positive gradient while this one has a negative. So anything here does not satisfy our solution. So here, nope, they don't match. You see, the colors are not the same. The colors are not the same. You see, colors are not the same. They're different. They're different. Different colors if you're looking from top to bottom. Even here, you see blue and orange. But then from this point here, do you see that here, if you're looking at the graph of F and you're also looking at the graph of G, the colors of these two graphs are the same, you see. So here the two graphs both have, so if you're looking here at the two graphs both have colors that look the same. So this here, you have negative gradient for the one while having negative gradient for the other, which is fine. And then if you carry on, you see colors are matching again. You see positive gradients for both of them. So only from 0 up until 180 do you have a scenario where both gradients are negatives, and also cases where both gradients are positives. You see, that's why your answer here, you're gonna need to say x is element of 0 until positive 180. You see, and you're not including the 0 and the positive 180 because at 0, you see one of them has a gradient of a 0 there, and then at 180 one of them has a gradient of a 0 there. So you see those points don't necessarily count because this gradient here is not necessarily positive or negative specifically. This gradient here is neither positive or negative specifically. So all this, you see, if you need more practice and stuff like that, then you already know what I was about to say. So let me not even say it. You see, just head over to the course platform and do the right thing. So anyways, here for 3 marks, they say determine the values of k for which this whole thing here will have no solutions. So in our case, we want to take note of the fact that cos 2x is our graph here. It's our graph of f, you see. So our graph of f, we need to take into consideration what has happened to it here. This is just a vertical shift. It has just been shifted 3 units upwards. You see, vertical shift 3 units up. They said for which values of k will this equation have no solution? Okay, so when they ask questions like these, right, where would this equation have no solution? This question, bluntly speaking, they're asking you for which values of x will this graph have no x-intercepts. That's basically what it means when they ask you where will a graph have no solutions, especially if it's just one equation. You say, where will this equation have no x-intercepts? So firstly, our graph has already been moved 3 units upwards. And then let's just look at our image here. If you look at our image, what do we know? Well, firstly, we don't know what this is, and we don't know what this down here is, but we can take information from our equations and automatically know. You see here, this is telling you the amplitude is going to be a positive 1. So that's for the graph of g. So obviously, if the amplitude is a positive 1 there, because amplitude, you always take the value here, always take it as a positive, you see. So for the graph of g, where is g? It's going to, this is telling us it's going to go to -1 and it's going to go to +1 up there, and both graphs technically are doing that. So here they're saying, let's see here. Firstly, this graph has been shifted 3 units upwards, equal to k. Where would this equation have no real solutions, or no solutions rather? So with a scenario like this, what you want to do for yourself, the first thing you want to do is, you obviously want to take k to the other side first. Yeah, so the first thing you want to do first is, you want to take the k over to the other side. There you go. And then this is what you want to recognize now. This question, yeah, it's quite intricate, I won't even lie. Generally speaking, since it's out of 3 like this, right, obviously in an exam, yeah, I would have obviously definitely left this for like last and stuff like that, once I've gone through like the easier stuff. And I'm not just saying this, you see, this is genuinely exactly how I went through my papers, you see. If stuff like this came up, even though I knew how to work them out, or maybe didn't sometimes, it was just one of those things where always keep in mind that when you're working on it, when you're going to be writing an exam, do the easy stuff first. Do the stuff that don't stress you out first, you see. Use your energy on those things and then come back to stuff like this, because here, this is quite an intricate question, because this question here, now, what you want to take note of is that what we're technically dealing with now, I'll try and draw it out as best as I can. You see here, just looking at this part here, what has happened in that part is that you have a cos graph, ne? And that cos graph was moved 3 units upwards. So it being moved 3 units upwards, it's going to, let's look at this image here. If your graph of f was moved 3 units upwards, instead of going from -1 down here to +1 up there, if it's moved 3 units upwards, you can imagine it's going to go 1, 2, 3. So it's going to be starting at +2 somewhere. Or rather, if this has moved 3 units upwards, it's going to go 2, 3, 4. So it's going to go from 4 to 2. So just looking at it, this is what you would see if you look at a portion only. And just a disclaimer, this question, level 5, 6 in my opinion, because so if your graph was moved 3 units upwards, this is what it would look like. So that's what this portion is stating. Now the negative k here, you want to take note of the fact that, you see, this negative here is causing a bit of problem, because What that means is looking at what k will be. If k is a negative number, it means that you would have a negative number here times a negative, meaning the effect would be you moving your graph upwards, you see. That's if k is a negative number specifically. Now, if k is a positive value, you see, if k is a positive value here, you'd have a positive here times a negative, meaning this would be a negative number, of which the effect of you having a negative number here, it means that the graph would be, moving the graph down. You would be moving your graph downwards if k here was a positive number, because having a positive value here is a positive value times a negative, so you would be moving graph down if k is a positive number. So thinking of that, right, they said here, determine the values of k for which this equation will have no solution. So obviously, if you're thinking of the way your picture looks now, right, if you look at the way your picture looks now, like this one here, the one that we have drawn here, this picture will look like this if, let's say, k was a 0. You see, there's no shift from this graph. If this graph here is not moved anywhere upwards or anywhere downwards, it will just look like this. So for it to continue to not have any x-intercept, what you can already see is that, firstly, your value of k here, you see, in this state, k is initially as 0. So what we can already say first is that if k is initially as 0, right, this picture here, for it to continue to not have any x-intercepts, it can be moved upwards all the way to infinity, you see. So the first thing we can say is that our graph of k, our value for k, the first thing we can say is that k can be anything that is smaller than 0, you see. Because if you think of any value that is smaller than 0 here, it will start moving, your graph will be moving upwards, you see. Any value that's a negative that you can think of, it will keep moving your graph upwards all the way to positive infinity, you see. So in terms of you moving your graph downwards, for it to also not have any x-intercepts, you would need to move your graph downwards a minimum of 4 units. Because if you move your graph downwards a minimum of 4 units, you will start having something like that, you see, because you see up here is a 4. So if you move it a minimum of 4 units downwards, you see here it will have solutions. So if you move it anything just more than 4 units downwards, your graph won't have solutions anymore, you see. So for that scenario to play out, we'll have to say that k, you see, for us to move it downwards, you see, k has to be a positive number. So we need to move it downwards. For us to move it downwards at least more than 4 units, it means that k has to be bigger than a 4. Because if you're throwing in values here that are bigger than 4, you will be moving your graph more than 4 units downwards there. Of which anything where you move your graph 4 units, anywhere you move your graph more than 4 units, your graph will not have any solutions, you see. So that's why here, question, yeah, 5 mark, 5, level 5 question, level 6 question. Don't even stress too much about it, because you see it's really not worth it. But anyways, these are your answers. Moving on to question number 7. Question number 7. We have just worked on, this question. To be honest, this question, it has depression written all over it. This one, But anyways, let's hope this one can brighten up the day, because it's been gloomy, brah. It's been, man, it's been. Anyways, let's see. Let's try to highlight this a bit. There we go. So let's read our description while looking at our image, while analyzing it, because you see, wherever you have a sketch, always analyze as best as you can, because analyzing is the name of the game. It says here points B, C, E. Where are those points? B. Okay, fantastic. B, C, E lie on the same horizontal plane. So that's the ground, you see. And then they said ABC is a rectangular piece of board. ABCD is a rectangular piece of board. Okay. And then it says here CDE is a triangular piece of board. Okay. Having a right angle C. Yes, having a right angle at C. Fine. So what you want to recognize is that this board here and then this triangular board here, these are standing upwards. You see that's why these angles are 90 degrees, because they're standing upwards. And then they said here, each piece of board is placed perpendicular to the horizontal plane, yes, and joined along DC. Yeah, so they're pasted here, you see, because they're standing upwards. Perfect. And then here they said, yeah, we can see it in the diagram. Then they said here, the angle of elevation from E to D is X. From E to D, the angle of elevation there is X. So that's super important. Thank you. And then it says here, BEC. Where's BEC? BEC is equal to 2X. Yes. And then it says EBC. Where's EBC? Yeah, EBC is 30. Whew, okay, yeah, you see, even if it's on the sketch, like, it really helps for you to like read your question like that. I know you may not believe me, but trust me, please. Asa believe. Yeah, okay, just pretend I didn't say that asa believe part, because it makes me sound like a crazy person, and you really can't be trusting crazy people. But I promise, the boy is not crazy. The boy is 100% sane. 100%. If you want me to prove my sanity, just hit me up on IG. And I don't know how you're gonna do that, but you can just be like, yo bro, I'm here to prove your sanity. That's gonna be the weirdest thing ever. But try your luck. But anyways, here it says, show that this is equal to that. So how many marks? 6. Ooh, let's see if I give myself space. Ooh, gang, baba, gang space. So with a question like this one, right, let's see what they're asking us nicely. They said, show that DC is equal to this thing. So you see, the focus there was, what do they want? They just want DC, they just want DC. They don't want Marvel, they want DC. They want Superman, they want Batman, they don't want Spider-Man. That's why they want DC. If you don't know what I'm referring to, what year were you born? 1984. Even if though, I'm sorry. Yo, that was so rude. Yo, my goodness. I'm so sorry. Well, DC and Marvel, those are like, competitors in like just Google it. But if I offended anyone, I'm so sorry. I am so sorry. Please do not cancel me in the comments. But if you try, now I can hold my own, man. I can hold my own. But let me not provoke anyone, because you never know who's listening. But anyways, yeah, they said show that DC is equal to this thing here. So your focus should be on DC. Just do what you can to get an expression for DC, and then eventually compare. Meaning, okay, the lucky thing here is your consolation just by looking at this is that they are giving you freedom to use BC the way it is, in the sense that if you look at BC, they're trying to say BC has no value given, but just use it in your calculations. So normally when you want to get a side, you always ask yourself, try and work with triangles. You see here, us working with this block thing here, this rectangle, useless. Don't even focus on it. It won't help you. Focus on triangles. Triangles make the world go round. So if you're gonna get DC, your only hope is this left triangle over there, this one here. And then this is a right angle triangle. You have X here. There you go. So the issue here is you need to get DC. So for you to get DC, clearly you need information inside this triangle. You need to get as much information as you can into this triangle. And the link to you getting information into this triangle, as we have already showcased in the trigonometry course, is always look for the line that connects you to more information, which is this one here. This line connects you to this triangle down here, of which that triangle down there has these pieces of information given. Now we said BC, just think of it as a side given. So we have BC, check, because you see BC is part of what we should have at the end. And then here we have two angles. You see, we have an angle there and an angle. We have an angle here and an angle here, and we are looking for EC technically, or CE. So with a scenario like this one, you may be thinking to yourself, but then how do you get CE? Likely here you can just use the sine rule, because look, you have an angle and its opposite side. An angle and its opposite side, you're looking for it. So that's definitely the sine rule. So let's just use the sine rule quickly. Here, the sine rule, we're going to say, what are we going to say? What are we going to say, bro? Oh, yeah. Because we're working out a side, we can put the side on top. Side and then its opposite angle. And then here, we have the side BC, its opposite angle. Perfect. Now you want to isolate CE, because that's what you want to work out, you see. So you isolating that, you can just multiply both sides by sine 30. There you go, there you go. So remember, here, if you want to simplify, which you should want to, I mean, like, why not? Sine 30 is just a half. So this thing here, this is just a half with BC at the top and then sine 2x at the bottom. See? Try to write it as best as I could. So at this point, you may be thinking, okay, it's out of 6, so you want to exercise patience, you know. You want to exercise extreme patience. If you do not exercise extreme patience with a question like this one, this question will moor you. You must be patient. Yeah, so don't get, yeah, I'll just stop talking. So with what you have here, let's see. We now have an expression for EC, so don't take it for granted, you know. Copy it and you paste it here. Perfect. You see, now you can get DC. DC, clearly you can just use normal trigonometry, because look, it's an opposite here and then you have an adjacent over there, so you can just use tan E. You see, so here tan x, which is this angle here, is equal to opposite over hypotenuse. Dope. And you see, remember, we want to work out DC, so you might as well multiply everything by the denominator so that DC is left on its own. There you go. DC is on its own now. DC has no competition now. Marvel is gone. But hey, Marvel is king, guys. Okay, like, let's not even have that debate. Marvel versus DC. Marvel wins all day, every day. Okay, like, all day, every day. DC does have cool characters, but yeah, they are boring, you know, just like the Flash. The Flash used to be so nice, and then they ruined it. I don't know why they did, but ish, they ruined it, man. But anyways, let's see here. So now we just need to simplify this as best as we can, because you see, that needs to end up with like a course and stuff like that. So here you just need to keep calm, because yeah, this is where things get easy. Because look, let's see, where's the 10x? Ooh, this here, you see, this is just a double angle, and I might as well change this already. You see, take this. This is going to be something interesting. This 10x can be changed to sine over cos x. So literally, this division sign here, you see, what that allows you to do is, when you change that 10, right? Remember this 10 here, we know it is just cos x, sine x over cos x. So this 10 here, when you change it to sine x over cos x, right? This same division line here is going to be this same division line there. Meaning that when you write out what you're going to write out, you can literally just have it as sine x at the top with BC here. And then at the bottom, you're going to have cos x here with the rest of the stuff. You see, that is mathematically 100% correct, which is why you're watching this video, because you want hex. And here you go. But all these are showcased on the courses as well, because anyone that takes the courses, I mean, huge advantage in my opinion. But anyways, so here now you see this here. Oh, I wrote it wrong. Please, please, no, don't make a silly mistake now. We've come too far for that, okay? Come too far. There you go. Now you can just use your double angles to like break this up. Because here now, this thing here can be written as that. And obviously from here you are kind of home free, because I mean, look bro, look. So here obviously this is going to cancel that, and then 2 times 2 is going to give you 4, and then this times this is going to give you cos squared. Kablemo. This and that give you cos squared, this and this give you 4. See, trust the process, baba, trust the process. And that is that. And then you move on to other questions. You see, nothing crazy, nothing major, just keep calm, don't stress. So here it says if x is equal to 30, show that the area of ABCD is 3 times AB squared. Wow. Okay. Well, I mean, the area of ABCD is just length times breadth, because I mean that's a rectangle, you see. How many marks is this question? It's out of 3. So obviously, it being a 3-mark question, you don't want to stress too much. But the lucky thing is they've given us x as 30. So I mean, they've given us x as 30. So what does that mean now? Well, it does give us something to do. Hold on. Show that the area of ABCD is 3 times this. So we need a way to get the area of ABCD then. That's what it means. Oh, okay. We just need length times breadth, remember. Okay. Because you see, it's just BC times DC. We need to prove that BC times DC is going to be equal to whatever this will be. Let's see if we have AB. Do we have AB? Where is A and B? AB is the same as DC. Okay. You see here, analyzing, Baba. We are analyzing like detectives, you know, like House, you know, from House. If you don't watch House, then see, if you do, then you know exactly what I'm talking about, you know, because House is like a beast. That guy, hey, he'll make you want to become a doctor. But hey, me, I'm fine. I'm fine, because me and blood, we're not friends. So let's see. Just remember, AB is just the same as DC. So just keep that in mind. Now, we said here, clearly we can just think to ourselves, what is the area of ABCD in the first place? And the area of ABCD, I mean, we can see it's just BC times DC. And BC, what do we have for BC? Remember, we have expressions for these two things. For BC, we don't have anything for BC. How sad. Well, yeah, we don't have anything for BC, that's for sure. But then we could get it if we wanted it. Well, they gave us this as 30, so this angle is given. Okay, I mean, they gave us angles, so we use them, you know. Let's see, there's not any other question after this, so let's use the angles that they gave us. You see, the angles that they gave us, they told us that x is a 30, so automatically this becomes a 60. If this is 60 and if this is 30, it means that this is 90. Perfect. Now we have all angles here. Now obviously, if this is a right angle triangle here, it means we can get BC using normal trigonometry. Perfect. So the only issue is that we have angles everywhere, but we don't have any sides given. You're my way. You see, now just when we were celebrating, now it's like why you do this? Why? So yeah, let's see here. CE. Yeah, let me just figure this out and then carry on. But anyways, yeah, BC times DC is going to be the area of this one. Oh, what we can actually just do, we don't need the actual values actually. What we could actually maybe do for now is we can just try and prove that the left side is equal to the right side here. So what I mean is ABCD, the area of that is just these two times by each other. So if you think of it, BC, you can just leave it the way it is. DC on the other end, you know, it's equal to this thing here, you see. There we go, you see. Let's just say we're working with the left hand side for now. There you go. So it's going to be here, this is over 1, so BC times BC there. And then they told us that x is equal to 30. So you could put this into your calculator. Let's see what let's see what 4 cos squared 30 gives us. It gives you a 3. You see, so down here you can put there. What does this give you? This gives you BC squared with, this is going to give you a 3 down here. The whole thing here is a 3. Perfect, you see. So that's what you get here. You're getting BC over 3. That's the left hand side, you see. Let's deal with the right hand side. The right hand side, we said it's just 3. Remember, AB is the same as DC. So don't forget that. So here it's like 3 times DC squared, which is going to be 3 times this thing here squared. And then we can already see that here, remember the bottom, we said if you throw in a 30 over there, then the whole bottom part is going to be a 3. Remember we said that? Yes, you do. That was just weird, but it's too late now. So the bottom part, the whole thing there is just a 3. And then look, this is squared, you see. Of which now, remember, always do the exponent first before multiplying. So here your exponential laws will tell you that the top part is going to be b squared, the bottom part is going to be 9. Of which when you multiply the 3 inside, guess what you get? You're going to get bc squared over 3. You see? And then here, with pride, you can literally just say therefore left hand side is equal to the right hand side. Whew! There we go. There we go. This was an okay question. This one was an interesting one. This one was quite, yeah, this one, it was quite interesting. It's quite dope, actually. Quite dope. I feel like a nerd, but it is what it is, man. It is what it is. If being a nerd means being like Bill Gates at some point, then heck, let's go, man. Let me wear that nedadry with pride. Let's wear that nedadry. Nedadry, is that even a word? Well, I don't know, but it sounds like a dope word, you know. Nedadry, like the art of being a nerd. Nerdadry. Anyways, yeah, that's just so weird. Like, wow, bro, how can you be saying this on a public platform? Peeps gonna think you're crazy, bruh. Hey, yeah, it's okay. It's okay. Let's just move on. Because it's too late. It's too late for me. Ooh, question 8. Question 8. Guess what? There's 2. Almost there, man. You're almost there, man. Keep on pushing. Keep on going. Like, obviously, if you're watching this over like 2 days or 3, that's perfectly fine, you know. This is not one of those things that you're just gonna go through all at once. Like, if you do, then you're a beast. Joe. Listen, Joe. Like you're the one, man. Like, you know, is it me just trying to, like, what am I trying to do here? Like, yeah, okay, sorry, we have a question to do. What am I doing? Question 8 here, it says, in the diagram, right, MP is the diameter. So we're dealing with Euclidean geometry now. So this is the realm where colors make the world go round. So in the diagram, MP, where's MP? MP is this diameter over here. Ooh, see how straight that was? Dope, man. Perfect, perfect, perfect. So they said in the diagram, MP is the diameter of a circle centered at O. So you see all this information, these guys, they're just trying to shower you with marks. They have told you this is the diameter. So what you do, you look for an angle that is 90 degrees. Look for an angle that is 90 degrees. And you see we have found it. Because why? If you remember, Dr. Cape Town, DRCPT. From the main channel, you see Dr. Cape Town helps you to remember things like diameters, radiuses, cyclic quads, parallel lines, and tangents. So here you see, the moment we saw diameter, we thought, oh, diameter, there's a formula, there's a theorem for that. Secondly, they spoke about a center. So we should think what? A radius. This is equal to this, and it is equal to that. So automatically, this angle there, we should remember it is equal to that angle over there. Do not forget that kind of information. It will help you. And again, we said, if they speak of a center, there's a theorem for that. Don't forget how there are tons of theorems. You see, automatically we know that I mean, just look at it. This is also, if you think of what you call exterior angles of a triangle, automatically apart from that, right, we can already see that this angle here is just double that one because of this theorem. You see, angle at the center of a circle is double the angle at the circumference. Don't forget that theorem because it works. Just like here, you see, you now know that M1 is half of O2. Just by analyzing, you're seeing those kinds of things there. And then also, you see, even here, O2 is also like double this one because you see angles subtended by the same chord there. One is at the center, one is at the circumference. So the one at the center is double this one. So much going on in this sketch. Hence why these marks are going to be so nice. They're going to be so easy. Anyways, here it says MP cuts the chord at NR. No. MP cuts chord NR. Where is MP? Where's the Minister of Parliament? MP cuts chord NR. Where's NR? Cuts chord NR at T. You see, they didn't say it bisects. They said it cuts. If they said bisects, then you would make this equal. But then they just said cut. And then it says here radius NO and chords PR. Where is PR? Radius NO and chords PR, MN, and MR. They're just lines that they have drawn afterwards. You see, they drew this, they then drew that. So they just try to describe the image here. Then they told us that R1 is equal to 69 degrees. So the rule of thumb is anytime you see, I feel like, well, it's if you have been going through past papers and stuff like that, then you know that obviously any Euclidean question where they give you like angles and stuff, yeah, then you're safe. They're trying to tell you that it's an easy question, so get your marks. So let's see what they want here. For 2 marks, they said determine giving reasons the sizes of these ones. So here they said R2. Well, I mean, R2 is quite simple because it's 90 minus the thing there. Because of what? What did we say again? Angle in semicircle. Because if you have a diameter, the angle here is an angle inside a semicircle. So here we're going to say R2 is equal to, hey, it's 90, Baba, 90. You see, and then your calculator, let's check what the calculator is going to tell us here. 90 minus 69, that's like 21, bro. 21 with it, forever 21. 21 is such a dope number. Okay, when it comes to age only, anything else it's like 21. What's that? So it's like, yeah, this is 21, perfect. 01, what did we say about 01? Where is 01? Oh, okay, well, we can just say what? Oh wait, oh yeah, we can trace it from here because this is 21, right? Let's see how many marks this is. It doesn't matter, we're gonna get those marks. With 01, we can start from here. We can say, you see, we're trying to trace. You see, when I say trace it, what I mean is don't just focus on this. Focus on stuff around it. Like this is 21. This, you know, it's 42. Therefore, this is 180 minus 42. You see? So, even though they're asking for 01, get them 02 first. You see, over deliver. Get them what they didn't even ask for. Get 02. 02, you know it is double whatever R2 is. What is the reason? What was the reason? The reason is angle at center of a circle. Angle at center of circle. Perfect. You see, so here, therefore, this is 42. So obviously, you can now say 01 is equal to 180 minus 42. What is the reason? The reason is angles on a straight line. There you go. Oh, I need to put this in the calculator. 138 is what you got. 138. I should not. There's no need to be singing right now, especially if you're gonna sing that. Like, nope. So M1 for 2 marks. What do they want with M1 now? Why do they want M1 for? So you see, the other rule of thumb is whatever you get, throw it onto your image. It'll help you. you know, it'll help you. So just throw it there, you know, just you can't have too much information. You see, it's like having too much money. What is that? There's no such. No, 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 no. No, 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 no. With cash, you gotta have more and 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 more. I think you get the idea. So those that are afraid of cash, hey, just give it to me. It's fine. I'll keep it for you. Okay, no, I won't keep it for you. I'll probably use it for like useful stuff, like getting an M4 or something. But anyways, where was I now? We're getting M1. M1 is, where's M1? They are, come on, these people are nyattering us too. Like, they want us to get M1 for 2 marks. It's fine. We'll get that M1 for you. You'll just give us your 2 marks and then we'll just move on. So we're just going to say M1 is half of O2. You see? The reason is angle at the center of a circle. There you go. And then they said for 4 marks. Ooh, 4 marks. We're being upgraded because, look, it was just like 2 marks, 2 marks, and then 2 marks. Now they're like double the salary, baba. But hey, some of us don't deal with salaries. But hey, it's fine. We'll take the money. We'll take the marks. Why am I saying money? These are marks. But you know, marks, money, you know, same fanana, bruh. But anyways, 4 marks here. They said M2. If, yeah, we should get M2, right? If it is further given that NO is parallel to PR. Okay, now you're telling us they're parallel. Why didn't you tell us in the beginning? You were keeping that information from us from the beginning. Now you want to tell us when we're done. It's fine. It's okay. I don't even know who I'm arguing right now, to be honest, because I'm like, bro, these guys said this paper when Angaz, I don't know, but when you're busy complaining. To who? For what? Let's just draw these parallel lines quickly. So these lines are parallel. So automatically, if this is 27. Okay, what did they ask again? Yeah, they're asking for M2 if these lines are parallel. I feel like this is like the easiest question in the thing, the whole thing. Like, it's so easy. It's so flowing. Like, it's so But wait, here I didn't put a value for this, did I? Oh, oopsie. Therefore, getting carried away. You see, busy talking. I think I should just calm down for a bit now. Maybe I'm running on adrenaline. Like, legit. Or am I? How can you say you're running on adrenaline? Is that even a thing? Maybe. If it is, then sign me up. M1, we said it was 21. This 21. What are they asking for? M2. Oh, M2. Like, these guys are so not serious. Are they seriously asking for M2 just there? What a wow. Maybe my brain is in like super hyper whatever mode. Oh, flow state. Yeah, flow state. If you don't know what flow state is, Google it, bro. Google it, girl. You want to know what flow state is, man. And I feel like I'm in flow state right now. I also feel like I'm going a bit crazy. Just a little bit. Just a little bit. But I promise the boy is still sane. If you wanna... Okay, never mind. Yeah, I am still sane. M2... Yeah, let's get M2. What? Okay, so with M2, right, literally all we're gonna need to do is let's use all this information. It's just so much. Because look, when you're getting an M2, try and focus on which triangle M2 is in. And then here, this is 90. You can easily get this angle because O2 is equal to P. Those are alternating angles. And then you can just use interior angles of a triangle to get M2. Simple. So here, O2 is equal to P. The reason is alternating angles, you see, which is equal to 42 there. You can do it like that. And then, what did we say now? M1 is equal to 180 minus these two. Wow. No, M2 rather. M2 is equal to 180. There you go. That's what you get here. 48. Fantastic. We get a 48. Well, we're practically done with this sketch, so I might as well put a value there because I don't think the next question is on that sketch. So let's move on. So this question out of 6, someone asked me this question like the day they wrote. like after they had written, like in the evening and stuff. So I exactly know what is going on here, and we can easily quickly go through it. But in the diagram here, they said ABCD is a cyclic quadrilateral. So again, you see the generosity, these people. But it's okay, we'll take it, you know. Why did I just complain because someone is being generous? Like, wow, bro, like what the hell? Here it says AB and DC are produced to meet at E. Where's AB? AB and DC are produced to meet at E. What's happening at E? Why are you meeting at E? Isn't it locked down these days? You're busy going out. But let's see here. AD and DC are produced at F. Okay, yes. Where is AD? AD and BC are produced to meet at F. Aren't like double dates supposed to happen at the same place? Because it seems like, you know, it's not going on. It's never mind. Here it says AFB is 2x. Let's see that. This is 2x. Make this a bit smaller, nyana. It's too big. And it's too dark. And then might as well label the other stuff because they're probably just going to talk about them as well. But obviously in an exam, you know, you want to go through it nicely. So here it says this is 2x, this is 3x, and that is x. Question number 1. Determine giving reasons the value of x. Okay. So this question, don't overthink it. Just keep calm. Just keep calm. So obviously the lucky thing with a question like this one is there's so much information given. But the one thing that stands out, right, without like beating around the bush or wasting any time, the one thing that stands out is we have a triangle over here. You see, if you're trying to work out a value, whether it's in trigonometry, okay, if you're trying to work out a value in geometry specifically, like analytical, 2D triangles, 3D triangles, that kind of work. Anytime you're trying to find like a value, né, always try and use what you may call a triangle to help you. It will speed things up, trust me. Like now, we have a triangle over here. And this triangle over here, the reason why we're focusing on this triangle is because this triangle has two sets of information that already have x. You see, there's 2x over here. And what else over there? What you got here? You've got a 3x. You see? Information galore. So don't take that information for granted. Otherwise, it will run away from you. You see, what you resist runs away from you. It's just like money. Don't resist money. Why am I talking about money so much? Maybe it's because the boy... Yeah, let me just stop talking there, otherwise I'm gonna review way too many things. So anyways, here, this is another triangle you could have, let's say, also used. You see, clearly either this triangle over here, because it has two sets of information, that is x, or this one here has two sets of information, that is x. So keeping that in mind, let's see what we can now do. Let's try and use some laws here. They told us that we're dealing with a cyclic quad. So the plan is to get more information in here, specifically an angle there, you see. So let's do what we can. So obviously from here, these two add up to 180 because opposite angles of a cyclic quadrilateral. Yeah, this is going to be quite interesting. This is going to be quite interesting because I think, yeah, let's use both triangles because this and this, right, give you that angle. Yeah, this angle here is going to be 180 minus 3x minus 2x. So that's going to give you minus 5x. Let's let the people know we know that. So that's like B2, right? And the big idea with a question like this one is you also want to keep in mind that don't overthink anything. It's better to just be writing things that will get you marks instead of maybe just sitting for too long and trying to just, yeah, hope to see everything from start to finish before you start writing, you know. Doesn't work. So here the reason is just Interior angles of a triangle. Oh, I didn't give myself too much space, but I gave myself enough. So that being said, you see we have a value here now, which is fine. Let's see what happens if we get a value. You see, let's use that other triangle as well, because it looks like we're gonna need to use it. So here, what is this? Is this D? Yeah, D2 is also, yeah, we're gonna use the same analogy for D2 over there. So let us do that. Might as well write D2 up here. D2 is gonna be equal to 180 minus 3x minus x, so that's like minus 4x. Or let's forget D2. No, let's forget D2. Like, yeah, look here, you see, look, this is 180 minus 5x, right? So automatically it means that this is 5x, because angle's on a straight line. It's gonna be easier here, because here we can get an angle in here, right? And then this is equal to 3x because of an exterior angle of a cyclic quad. But let me not rush too much. Let me just do things bit by bit. So here we say this is 180 minus 5x, right? And then we're saying this is 5x because angle's on a straight line. There you go. There you go. But it would make sense if this is coming after this, you see? Yeah. Whew. Now we can say C1 is equal to 3x because exterior angle of a cyclic quadrilateral. Because you see, full triangle, full information. You see, exterior angle of a cyclic quadrilateral there, and there. So let's do that. So you see, what we can also showcase here is, don't be afraid to change your mind if it's going to help you. You see, like here, we were thinking of this triangle and also maybe thinking of this other triangle here, but look where we are now. Look where we are now. Bigger. Look where we are. Okay, never mind. Let's leave that. So obviously now we can just say these three added together give you 180 because of interior angles of a triangle. And then let's solve for x. Here you got what? 6 plus thingy, that's 9. Divide by 9 on both sides. X is equal to 20 degrees. X is equal to 20 degrees. 20 degrees. Nothing crazy here. Nothing major. Nothing too fantastic. But anyways, that's that for that question. With the next one, we are here. We are all gathered here today to do question 9. But let's see, how was question 8? Yeah, question 8 was a party. Oh, was a party, man. But question 9, here we are. With question 9, we just have to be careful, because here it says for 6 marks, it's a theorem that we need to prove. So, let's see which one it is. In the diagram, ABC is a triangle. D and E are points on sides AB and AC, respectively, such that DE is parallel to BC. It says, in the diagram above, right, prove the theorem which states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. For 6 marks. Anyways, so this theorem is showcased, I think, where? It's there on the main channel. It's there, yeah, so many places. But anyways, if you're gonna prove this theorem, right, you see here they want you to prove that AD over this is equal to AE over that. So to do that, this is what you need to do. You need to make use of 2 specific constructions, you see. So I'll use colors here to help us. Let's start. Let us begin. So with this theorem, right, all you want to do is you want to think to yourself, okay, fine. You don't matter about cramming it, just know the process. So the first 2 constructions will need to be a line from D that is going to AE. they have to meet at an angle of 90 degrees. That's your first construction. So you can construct this and label it K, you see. So let me write that out. Const K, construct K perpendicular to AE. That's the first thing you do. Let's take another color. Secondly, you need to go from this point here and construct H. There you go. And you need to also specify that that line needs to be perpendicular to your triangle over there. Perpendicular to this line here, right? Line A what? AD. Perfect. Now, what you want to recognize, right, is you also need to construct two more sets of lines, which are going to be BC, or rather BE, and then you need to construct DC. There you go. Yeah, this theorem is, honestly speaking, low-key messed up. So yeah, not like I'm messing it up. No, I'm just saying it's just like so ridiculous. It's like, why do you even want us to prove that? You know, just sometimes math is like, hey, mathematics, why? But it's okay, man. As long as you're on earth, don't let nothing bully you, okay? You gotta stand your ground. You gotta stand your ground, bro. Stand your ground. And when I say bro, I'm definitely referring to both genders. I hope you know that. Anyways, const. We said you have to construct DC as well. Whew. So yeah, your constructions are now ready to shine. So this is the big issue with what we're looking at here. You see, when you've made all these constructions, you want to take note of three triangles, you see. The first one is triangle ADC. Triangle ADC, you want to recognize that if you're looking at triangle ADC, you want to think to yourself, you see this perpendicular line here, this H is obviously a perpendicular height for your triangle ADC. If you look at K can also act as a perpendicular height for ADC, because this theorem you work with ADC twice, but then you work with ADC once if you're referring to this triangle as well down there, and then you work with ADC when you're also referring to this other triangle down here. Now the big idea here is you want to recognize that if you're thinking of H, right, let's talk about H first. If you're thinking of H, you see H is this line over here. It's the perpendicular height for your triangle here, and you want to recognize that H is also the perpendicular height of triangle DEB. Yes, because if you look at triangle DEB, right, it's practically standing like this. You see, there's D here, there's B here, and then there's a top up there, which is E. This is the highest point. So if you drop a line going straight downwards, you see, this is your perpendicular height if you're thinking of DBE. It's the same idea with this triangle over there, you see. Its perpendicular height is K over there, you see, because they are considering EC as the base. So if you're looking at that other set of triangles, right, K here is clearly the perpendicular height of your ADC as well. This can also be considered as its perpendicular height, and then obviously here, you see, that can also be considered as the perpendicular height for this triangle if you're looking at this point going straight towards the base here. So with all that information being put out here, we just want to write down formulas for each of our triangles here. So let us begin. Let's do the green ones and then we do the pink ones afterwards. So in terms of the green ones, you see, we're going to talk about area of triangle ADC. What we know is that the area of ADC divided by the area of this triangle is going to be equal to the area of ADC divided by the area of this triangle. There you go. Your reason for that, now your reason for writing all this will literally just be triangles, or rather proportionality of triangles between parallel lines. There we go. Now we just need to write down formulas for each of these areas. And the formulas for each of those areas will all just be half base times height. But for the green, you see, for the green, what you need to just take note of is that let's get an area for ADC. An area of A for ADC, remember, you want to consider AD as the base because H is the perpendicular height, you see, according to your construction. You see, don't forget that this is H, your perpendicular height. And for the red one, K is your perpendicular height. You see, perpendicular height here, perpendicular height. For these ones, perpendicular height there, perpendicular height there. So let's highlight what will the bases be for each of these. So obviously this would be the base, and then this would be the base. For these ones, this would be the base, and then this would be the base. Do not forget that. Okay, so let's do it. Let's do it. Everything seems to be working along just fine. So here the area at the top here, right, is going to be a half. What's the base? The base is AD. What's the perpendicular height? H. Over. The area of this triangle is going to be a half. What's the base? The base is BD, or DB rather, if you want, because of this. And then the perpendicular height is just H. You see, that whole thing there, we said it is equal to this. The area now, if you're looking at the pink side, you see, the area of ADC, you want to look at it as half. And then what's the base? The base is AC. No, E. This is supposed to be E. Excuse me. The whole time this was supposed to be E. So it's a half. The base is AE. And then the perpendicular height is K. And then this one, same thing, you see. The area is a half. The base is EC times the perpendicular height K. Whew! Now the cancelling happens and you will be home free. You see, this cancels that, this cancels that, this cancels that, this cancels that. And then therefore, and then you're done. You get your 6 marks. You do like a mini victory dance in the head, and then you keep on moving forward. So what are we looking at here? It's a 6-mark question. Well, description first, you see, description first. Always look at the description first. So in the diagram, M is the center of the circle. Okay, yes. M is definitely the center of a circle. And what we want to take note of is the fact that you see this line here is not passing the circle, or it's not passing the center, so it's not a diameter. Do not forget it. It is not a diameter. So what do we have here? A, B, H. Yeah, if you hear my stomach, yeah, just know the boy is hungry. And I just want to get this done before I eat, you know. Just want to get this done before the boy eats. Because food is more satisfying when you're proper hungry. You know what I'm saying? But anyways, I think after this, as a reward, you know, probably get some McD's or something. But anyways, A, B, and C. A, B, and C are points on the circle such that AC is equal to BC. So let's see here. Where is AC? Hey, yeah, where is A, B, and C anyways? A, B, C. Yay! A, B, C, D, E, F, G. What the hell, dude? Like, what is that? It is a point on the circle such that AC, where is AC? There we go. They said AC is equal to BC, yes. Then they said PA is a tangent. Where is PA? Ooh, yo, is P and AR tangent? Yo, that's interesting. They said PA is a tangent at A. Yes, so let's highlight that line because that's, super important. What else did they say? They said here PQ is drawn parallel to CA. Okay, let's see here. PQ is parallel to CA. Where's PQ? PQ is parallel to CA. Yes, we can see that. We can RC that. Thank you. Danko. And then what else? What else you give? What else you give? Yeah, this is drawn parallel to CA to meet at BA. Where's BA? Meaning at British Airways. Fantastic. No, what did it say here? PQ. Where's PQ? PQ is parallel to CA to meet BA produced at Q. Wow, okay, that's the dumbest description I've ever seen. But you could have just, these guys, why are you trying to make things so complicated? We are seeing that these are parallel, fine, we get it. And then this one is a line that's touching both of those lines. Just say that or something. But hey, sharp, but you're sharp. Let's see, here it says, yeah, fine, they've just told us what's on the sketch there. And then they said BC produced meets PQ at R. Where is BC? BC produced meets PQ. Where's PQ? Meets PQ at R. You see, all this here is important, as annoying as it may be sometimes to read. Yeah, you kind of need to. And then he says here, yeah, it's produced at R, and AR is drawn, and then they just drew a line AR over there. So AR, they didn't say anything about AR being a tangent, so don't assume stuff, you see. Assumptions, they're not good, guys. Don't assume stuff. Don't assume stuff. So if you don't know whether or not that person actually, okay, never mind. What I'm trying to say is don't assume things. Find out. Go find out. Okay, shoot your shot. Get the answer, but be prepared to feel the pain as well. So don't say I did not tell you. But anyways, for 6 marks here, they say determine giving reasons for other angles equal to x. These are usually I was about to say my favorite kind of questions for Euclidean, because I think they are, they're easy, they're doable. You get 3 marks, like here, you see. As long as your theorems are like on fleek, you're gonna have a party. Yeah, a party, because look, here x is equal to a1. Why? Well, because these are corresponding angles, you see. Because of Dr. Cape Town. Dr. Cape Town is stuck in my head. DR CPT, you see. We don't have a diameter, we don't have a radius, but do we have a cyclic quad? Nope. Do we have parallel lines? Yes. So what do we need to remember when we hear parallel lines? Fun. And then do we have a tangent? Yes. So what we need to think of? The ten-chord theorem and other theorems. You see, ten-chord theorem and stuff like that. Don't forget that. So here, yeah, corresponding angles because we have parallel lines there. So let's just write that down. Did I just write corresponding full out? What a wow. What a wow. But anyways, let's carry on then. So you see, whatever you spot as x, trust me, label it. Don't let it go free without you labeling it, because it will help you find others. You see, once you've found something that is equal to x from the original one, usually you want to use the one that you would have found to get the others. You see, like now here, these are equal, so automatically this is also equal to x because those are angles of an isosceles triangle. So you see, b here is equal to a1, which is clearly then equal to x because base angles of an isosceles triangle. Base angles of an isosceles triangle. If you said angles of an isosceles triangle, I think that should be acceptable. Base angles. There you go. Base angles of an isosceles triangle. So how many? That's 2 now. 1, 2. So with our next 2 values for x, what we gonna do? Well, technically, you see, we just got our isosceles triangle thing in there, which is fine. Now we can use the 10 chord theorem, like we said. You see, because we have an angle over here, and then obviously according to our 10 chord theorem, you get a tangent over here, so, and then you get a chord over there, you see. So that angle here is also equal to x. The reason is there is a chord here, there's a tangent over there, and then this angle is subtended by this chord here. So this one is equal to that one. So let's just tell them that a2 is also equal to x. Let's let's pile on the information is what I want to say. 10 chord theorem here. Perfect. And then now look at this. Look at that. Alternating angles. So P is equal to, what are you here? What are you? P, right? Yeah. P is equal to X because of alternating angles. Perfect. You give them what they want and then you run, Baba. Just run. Don't even look back. Just run. When I just run. So anyways, for 2 marks here, they want us to prove that ABPR is a cyclic quad. Where is ABPR? Let's see here. There we go. They want us to prove that this shape is a cyclic quadrilateral. Now, you proving that this is a cyclic quadrilateral, remember, you can either prove, that there's an exterior angle somewhere that is equal to an opposite interior angle, or you can prove that angles that are subtended by the same line are equal, or you can then prove that opposite angles add up to 180. So you proving opposite angles adding up to 180, yeah, that doesn't look like it's going to happen here. You proving that there's an exterior angle equal to an opposite interior angle, that one is worth a shot because we only have 2 exterior angles. There's this one here. We can prove that this is equal to that, but that's a long shot. Or proving that this is equal to that, that's also a long shot. So our only option left is the zigzag one, where you have like lines crisscrossing, and you need to prove that you have 2 angles that are being subtended by the same thing that are equal to each other. And our best bet looks as though it's going to be this angle here and that one, or even no, we have them already. Look at that. Oh, thank goodness for eyes. So you see, there's AR here. See, AR over there, and then there's B going there, and then there's R going to be there, you see, and then there's P here, like that. Yep, you see, that's one way you can prove a cyclic quadrilateral as showcased in the cyclic quadrilateral tutorial on the main channel. You see, as long as you can prove that 2 angles that are subtended by the same thing are equal, then you'd have proven a cyclic quad. Like here, this is equal, it's proven, and there are 2 angles going to the same line. They see angles subtended by the same line, or angles in the same segment. So here you're literally going to say P is equal to, what is this here? That's like ABR. Here, proven, you see. So because we're spotting that this is a cyclic quadrilateral, our reason will be angles subtended by the same line are equal. There you go. There you go. There you go. There you go. You get your 2 marks. It's the main reason why this was just a 2 mark question, because there's really nothing crazy going on here. You get those 2 marks and you keep it moving. So 3 marks here, they said you should prove this expression. Prove that AB over BQ is equal to BC over QR. So these questions, just try and focus on triangles that may be similar, because yeah, that's your best bet. So here, let's look at BA. Let's check where BA is. Here they're talking about BA and BQ. BA and BQ. Where is B even? Where is B? There's B over there. BA and BC. Was it BC? BQ. There's a Q in this thing. Oh, there's a Q there. Yeah. So BA and BQ is equal to, yeah, BA over BQ is equal to BC over QR. Let's see here, BC over QR. Wow, guys, like what the hell? You're joking. Like, what a wow. So questions like these, obviously, I mean, they're not the nicest things to do if you have not gone through the whole thing, and if you're not like 100% comfortable about your marks and stuff like that. These are the kinds of things to do right at the end, because you don't want to waste your time being frustrated and annoyed and stuff like that. I mean, there's a reason why Euclidean geometry is right at the end, because this topic is annoying. But anyways, it is what it is, you have just got to dollar what you must. But anyways, with a situation like this one, I think we should just not panic, because you see, when you see how this is just off, this QR here is just, and this BC, it's just making things seem a bit too weird. Now the only thing we can already see is that BC is equal to AC. So as long as this was AC, this would make life so much easier. So let's start there. Let's just tell them we know that BC is equal to AC. That will make life so much easier. It's given, you see. Therefore, what we should actually just be proving is this. This is what we should actually just be proving. Of which this makes sense, because with our triangles, right, the way our triangles are laid out, we have these ones here where some proportionality shandies is happening. We have the B, C, like that, you see, of which we have parallel lines here. So as long as that's happening, we know that we have proportionality of similar triangles playing out, because this is equal to that, this is equal to that, and then this is a common angle. So in light of all that information, got it, and we want to do what? We want to paste it. So if you think of what we have here, right, obviously BA over yada yada yada, all this stuff here, we can just write it out because of proportionality of similar triangles. So we can just quickly, easily prove that these are similar, and then we're home free. So here, let's see here, you have, we need to work with the two triangles, like triangle BAC and triangle BQR. You see, those two triangles, we need to work with them. So here we're gonna need to say in triangle BAC and triangle BQR, what do we know? We know that B is going to be common angle. We know that R is equal to C there, so it's like QRB is equal to ACB. The reason there is just corresponding angles. And then here, Q and that are equal, so it's like RQB is equal to CAB. The reason is just corresponding angles as well. So you see, we've now proven that these are similar. So here you can just say, therefore triangle BAC is similar to triangle BQR. What is the reason? Angle, angle, angle. You see, so as long as you're proving that these are similar, now you can write out whatever you like, as long as it's corresponding. So here you can now write, therefore, let's use a different color. It's too similar. This is okay. So here we can then say, therefore, BA over BQ. You see, because it's going to be BA here. Let's get a red, man. Come on. BA over BQ. You see, from small triangle and the big one there is equal to something from the small triangle here. Let's maybe use a different color for those ones. There you go. And the reason for that will be proportionality of similar triangles. Whew, hectic. So obviously we can then just replace that AC. You see here, therefore, and then you'll be good to go. You'll be good to go. Whew, yeah, hot. 6 marks, but hey, they'll just give you 3. I think maybe because of this, because this is all just, you know, simple, quick, straight to the point. Guess what? We have made it. Like, oh my gosh, I'm so excited. Like, it's the last question. Oh, this is so amazing. Like, oh, the boy is so happy. Like, oh my god. Okay, excuse me. Yeah, I'm done being extra now. Okay, that is definitely a lie. But anyways, 3 marks here. Oh, no. We haven't read the description, bro. In the diagram, TSR. Where is TSR? TSR. Yes. Ooh, okay. That's tempting. Oh, they did say it's a diameter. Yeah, you see, this is the center of a circle. They say TSR is the diameter of our circle. So if they told us it's a diameter, then best believe that's useful information because of Dr. Cape Town, you know. So yeah, if you are listening to me right now and you're not sure what I mean when I'm referring to Dr. Cape Town, what a wow. But it's all good. It's in the main it's on the main channel. Just look in the Euclidean Geometry playlist on strategies on how to, what is it called, that tutorial? Strategies on how to solve Euclidean riders. Yeah. But anyways, anytime you have been given a diameter, right, just remember, you see, you have an angle that's equal to 90 there. And then also just remember, automatically when they give you stuff like that, let me actually just write it down again, DRCPT. But I've been saying it already. But anyways, there's a radius here, there's a radius there, and there's a radius there. So automatically you already know that this here is double whatever that angle is there, because an angle at the center is double an angle at the circumference. And then automatically you know that this is equal to this, because those are angles inside an isosceles triangle. Here, this, you already know it's equal to that. So also you have angles being equal to each other over here. Hey, when I write over here and there. So plenty of information just being given by what they have just told us here. And then they said here, it's a diameter of the largest circle having center S, chord TQ of the largest circle. Where is TQ? Chord TQ of the largest circle cuts the smaller circle at M. And then it says PQ is a common tangent to the two circles. Ooh. You see, when they speak of common tangents, hey, that's when they want to make you get a lot of marks without wanting to give you a lot of marks bluntly. So anyways, it's a common tangent. So if you can think of our Dr. Cape Town, you see, anytime they speak of tangents, think of things like the 10-chord theorem, things like a tangent being perpendicular to a radius, and then obviously tangents from a point, if you have 2 of them. But then in this question, I mean, tangents from a point does not apply because we only have 1 tangent anyways. But with this 1 tangent that we have, you see, let's think of the 10-chord theorem, because automatically here we can already see that this angle here, it is equal to that angle over there because of the 10-chord theorem. The 10-chord theorem is powerful. You see, a point there at the circle. Whoa, I lied. What a lie, bro. What the hell? What a lie. What a wow. Oh, I meant this one up here. Whew, thank goodness. Yeah, you see, because you have a tangent here and a chord over there. You see, this angle here is also going down to that chord. So that's definitely the 10 chord theorem. What else? For the smaller circle, is there a 10 chord theorem? It's not happening. Nah, not really. But there is a tangent. They didn't tell us there's a radius here or anything. So yeah, I think with the tangents, we'll just look at them some more later. So with all this being given, they said, yeah, it's a common tangent, and then said TP. Yeah, okay, this is important. RP, where is RP? RP is perpendicular. Okay, yeah, fine. Thank you very much for that information. Much appreciated. This is really not. Thank you. Thank you very much. Thank you very much. So for 3 marks, right, they said we should prove giving reasons. Okay, that SQL, we should prove that SQ is the diameter of the smaller circle. Okay, I mean, if it's for 3 marks, we can do that for you. We can definitely do that for you. Not a problem. Not a problem. Not a problem. So if you're going to prove that this is a diameter, I mean, focus on this angle here, because I mean, if this is a diameter, then this angle has to be 90 degrees. If you can prove that this angle is 90 degrees, you're done. So might as well focus on that. And we can prove it is 90, because you see our constructions and our analyzing helped us to put this as 90. So these are parallel lines anyways, you see. So parallel lines, automatically we have here co-interior angles. Obviously, if one is 90, the other one has to be a 90. So let's just put the information we got here. You see here, these are parallel. I feel like we didn't do Dr. Cape Town justice because we skipped P. Parallel lines. So what we're going to tell them is that we know that TQR is 90. Let's tell them that first. What is the reason? The reason is angle in semicircle, because it's an angle subtended by the diameter of a circle there. And then let's tell them that M2 is also equal to 90 because of co-interior angles. You see, the moment you've shown that M2 is equal to 90 degrees, then you are done, because all you want to then say is therefore SQ is the diameter. You see, M2 is the diameter, and then in brackets you can easily put there. There we go. This last part, if you left it out, that's still 100% fine, because the key issues are these here. You showing that this is 90 and then this is also 90, because as long as this is 90, this is definitely a diameter. So you move on to the last question. Wait, snap. Second last. Blixum. So anyways, 6 marks here. They said we should prove that TR, you see, they have started with their things. Hey, yeah, Euclidean, where did you even come from? Hey, let me not hate. But obviously, if Euclidean is an issue, guess what? There is a Euclidean geometry course. You see, so on the course platform, your best bet is to just go for the all-access pass, because the all-access pass gives you access to everything on the course platform. So anyways, here it says TR is equal to RQ squared over RP. So for 6 marks, you see, they said RT, you should prove this expression. So before you worry about that expression, you need to find out where is RT in the first place. So we see with expressions like these, right, also try and see from our previous questions here. You see, just try and prove similarity first before you worry about these. But anyways, let's see RT. Where is RT? RT is this whole thing there, fine. And then RQ is this small one there. And then RP. And then there's RP. I mean, I think that is a bit blunt, because automatically you can already see there is this triangle over here. There's RT and Q here, right? Furthermore, you have this triangle over here. Now, what you want to recognize is that, you see, RQ is a common side, and here there's RQ squared. Then there's RT here for the big one, perfect, and then there's RP for the small one. So if you look at what I'm basically trying to say here, and if you can also recall from like the Euclidean geometry course, you see where there's few, there's definitely 5, because here they're talking about RT, right? RT is for this triangle only, but then here they're talking about PR, you see, which is for this one here, you see. So two triangles, two sets of lines, you're obviously going to need to prove that these are similar first. As long as you can prove that these are similar, trust me, this is just going to come out, and these are going to be free 6 marks. So in terms of proving similarity, as we have already heavily stated within the course, we know that the big issue is you need to make sure that your triangles match. So in terms of the way you're going to label your triangles, you see where Q is for the 1, you see where Q is for the 1, you'll need to put P for that one. And then obviously, luckily for T, we have to put Q for that one. You see, because we've already shown that this Q here is equal to that T. We haven't shown it yet, but while analyzing, we proved it. So we know those two go together. Secondly, we know that these are both 90. That's a given. You see, because proving similarity, you just have to prove that all 3 angles are equal. So as long as you can prove that any 2 pairs of angles are equal, the third ones are automatically equal, you see. So in terms of naming your triangle, if you're going to name these RTQ, you want to name this one RQP. Yeah, that's what you can do. So let's do it like that. Let's name these 2 triangles what we are about to name them. So let's take these, maybe let's copy only, let's not cut, let's copy and paste here. Paste, there we go. Thank you very much. I feel like paste feels so much better than paste. Paste is so boring, you know. But anyways, so here we're gonna tell them what we're about to do. We're gonna say in those 2 triangles. So in triangle what? Triangle RTQ and triangle RQP. You see, we've stated which 2 triangles we're working with. Now that we've stated which 2 triangles we're working with, let's tell them what we know. We just want to show them that R here is equal to this R. This T is equal to that T. And then lastly, this is equal to that. Let's show them that. So why didn't I just color code it the way I did here? There we go. So this is already giving a roadmap to follow. So you just want to give reasons for those things there. So the funny thing is, ones that are a bit too difficult to prove in terms of angles being equal, don't start with those. You see, start with the blunt ones. Like Q here is equal to that P there. So let's do that. You see, this one you can call it TQR. Let's get a neutral color here so we don't get confused. Oh no, this is fine. So TQR is equal to QPR, you see, because you're just gunning for this one here. Your reason there is given. They gave it to you, right? No, is it? No, it was not given. We know they're both equal to 90, you know. So you can just say they're both equal to 90. And then proven, because you proved that that one is equal to 90. So that's the easy one first. The next one is Q, the Q here and the T there. We said they're equal because of the 10 chord theorem. You see, analyzing helps because you're saving a lot of time there. So let's see here. You're gonna say, we can call it RQP equal to RTQ. What is the reason? 10 chord theorem. There you go. Now the reason why you want to do the easy ones first is because the third one that you will be having a hard time finding a reason for. You don't even need to get a reason for it. All you can say is these are equal because of interior angles of a triangle. Because if two sets of angles are equal, the third ones automatically are equal because of interior angles of a triangle. So here, you're just going to say TRQ is equal to QRP. What is the reason? Interior angles of a triangle. Ah, fantastic, fantastic, fantastic. And then now you have proven that they're similar. So you can then say, therefore, triangle TQR, RTQ, I mean, is similar to triangle RQP. And the reason for similarity is always just this one. Angle, angle, angle. You've proved that all three angles are equal. Now, obviously, if you've gone through the tutorials on the main channel, you know that as long as you've written out all that we have written out here, you are able to write out different expressions based on your wording here. So here you can then say RT over RQ. Let's see, we need RT and RQ, and then we need something that is RP in it. So we can say here RT over RQ is equal to RQ over RP. You see, as long as they match. Your reason here will be proportionality of similar triangles. Whew, there you go. There you go. Now look, just cross the multiply and you're done. This times this, and then this times that. So here, this times that gives you this squared. Let's see. Come on. Oh well. Just multiply this and that only then. Then leave this one down here. You don't have to cross multiply. There we go. Just multiply both sides by QR there. And then you're done. And then you're done. They'll give you how many marks? 6 marks. Ooh, here we made use of space. Yo. Anyways, for how many marks here? For the last 6 marks. Oh, this feels so good. Oh, feels so good. So satisfying. Excuse me. Anyways, for 6 marks here it says, if MS is 14, where's MS? Where are you? Ukokaijo, 14. Okay, sharp. Let's see. This is 14. Now what? What you want us to do for these 6 marks? We are so ready because we have thrashed this paper so hard. We're ready for anything, man. It says if MS is 14 units and PQ is square root of this. Where's PQ? Square root of 640. Where's PQ? Square root of 640. Let's just write that down. Fantastic. Then they said here, calculate giving reasons the length of the radius of the larger circle. Okay, this is going to be interesting, I guess, because I mean, the one thing I can safely say is anytime you see a given actual numbers to work with, trust me, use them. So we have gotten, you see this expression here, don't underestimate how you have worked out this expression. This expression may be very useful to us, you know, so yeah, don't forget about it. Let's see, they spoke of MS. Yeah, okay, fine. The funny thing is, well, not funny, it's just like, the interesting thing is, it looks as though we may need to, oh wow, yeah, looks like we have to do some funny shandies here, because if they're asking for the diameter of the large circle, it means we eventually need to get a length for TR, like the whole length of TR there. So I mean, my gut feeling, right, you see here, I think I'm also just going to showcase why it's important to go with your gut, because I mean, just looking at this question here, my gut legit is telling me to prove that this small triangle here is similar to that small triangle there, so that we can use their values to somewhat eventually incorporate this triangle here, because look, this one here, if this small triangle here, right, let me just show you which one I'm talking about. This one. If we can show that this small triangle here is, well, wow, bro, come on. The small one is already, this one here is similar to the big one here, right? So it means that automatically it is similar to this small one down there, you see? Because, I mean, look, this is 90, this is 90, this is a common angle, and these are corresponding angles. So, yeah, all those three triangles are similar to each other. And the three triangles I'm talking about are these three over here. These three triangles are all similar, like all of them are similar, all of them are similar. That's how we're going to get the diameter here. Trust me, trust. So this is like square root of 640. This is like 14. So yeah, we just gotta be creative, you know, just gotta be creative about it, you know, just gotta be creative about it, because yeah, it's like everything is right in our face, but it's just like, ish, yeah, nah, it just doesn't want. But let's see, we have TR, we have RT. Oh, okay, we have RT here, and then what did they give us? They gave us PQ. So we have PQ, we have, yeah, let's just try and do something with these two here, because yeah, I've been blabbing for too long, because I'm literally trying to wrap my head around it. But the more I blab, the more I'm just gonna get confused. So let's just get on with it. So here we know that our task, we have already shown that these are similar. Our task is to just show that all these three are similar to each other. All these three are similar to each other, one way or the other. Now for us to do that, we just need to show that at least one of these two triangles is similar to that one. Now let's pick this one and the big one there, because those are the easiest ones to prove. Yeah, we can easily prove similarity with those ones. So let us see here quickly. Yeah, I'm just gonna, yeah, I don't even need to be showing it. I just need to just write it out, because all I need to write out is that this is equal to that, and then this is equal to that, and then a common angle. So let's just do that. Whew, finally, the last question. Yeah, this question here is no joke, because clearly this is not my first attempt. Trust me, I have been attempting this question for quite some time, but guess who cracked first? The question. But anyways, with a question like this, we definitely need to use this, you know, because yeah, here they said if ms is equal to 14 units and pq is equal to the square root of 640 units, calculate, giving reasons, the length of the radius of the circle. So before even diving into anything crazy, they want the length of the radius of the circle. But then this is our gateway, because you see TR here is the diameter of the circle. So the other thing is that you see what they have given us here. They have given us this length here, and they've given us this length over there, you see. So the idea here is you mainly want to focus on things like, you see here they spoke about the radius, you see. So you want to think to yourself, okay, if you look at this triangle over here, this triangle over here, it is definitely similar to the big one, you see, that we know. So we can just state that first, you know, nothing major, nothing crazy. Similarity here, TMS, in triangle TMS and triangle TQR, we're just going to prove similarity by showing that all three angles are equal. This equal to that, this equal to that, and then that equal to that. For T, it's simple. Let's be quick. That's common angles, or rather, that's a common angle. And then here, let's see. M1 is equal to that angle for Q there. You see, we've proven that they are both equal to 90 because this is 90 and this is 90. And then here S1 is equal to R1, corresponding angles. Even here you could have also written corresponding angles. But anyways, our task here was to show that these two are similar first quickly, because we can now do proportionality stuff. So here, therefore, these two are similar to each other. So as long as we've shown also that this small triangle here is similar to the big one, now we can write expressions that incorporate the radius with this length here. So we can bring all that information into this triangle to help us eventually get our radius. So the first thing we can write here is that ST or TS over SM is equal to TR over RQ. You see, we're going to write TS over SM is equal to TR over RQ. You see, for the big one there. Our reason for writing this would be proportionality of similar triangles. Whew. Perfect, 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 perfecto. So now here the magic happens. So the good news is that you see, with everything that we've written down here, TS, this is the radius, SM is 14. But then the next step here, what you want to recognize is, you see, we said we need to incorporate this into what we have here. Now the best way to incorporate what we have up here is by taking into consideration that there's TR here. You see, TR is the same as RT. It's the exact same thing. And we know that TS is just half of RT. You see there? TS, you see, it's just half of RT. So you may want to write TS in terms of RT. It's going to make your life so much easier. So here, half of RT is going to be equal to RT on that side over this thing. You see, we've thrown in our 14 there. And then if you want to simplify, obviously here you can cross multiply first. And then you can easily just divide both sides by RT so that goes away. And then look, we're getting RQ, which is us getting more information into our triangle, which is good. And then dividing both sides by a half, you're going to get a 28 there. That's for RQ. You see, you've gotten a length for RQ. So this is sorted. Perfect. Now for RP, luckily you can just use Pythagoras theorem, because here you now have RQ, right? RQ, you got it to be 28. So Pythagoras theorem is equal to this, right? So obviously here, this is what you're going to have. So let's just take this down and get a value for PR, or RP rather. Oh yeah, so we got our RP here. Yo, so quiet for so long. But anyways, so now that we've gotten RP, we know that we have a value for this, we have a value for this, so we can just get RT and chop it in half, you see. So here, therefore, RT, we know it's equal to RQ squared over RP. There you go, you see. And then here we know that 2 times whatever ST is, that's what RT is. And then you multiply both sides by the 2 there, and then our final answer is just 28 squared divided by 12. No, divided by 24. We're getting there, 32.67. Whew, would you look at that? Look at that. We have just finished the paper. What a big wow. Yeah, this paper was, yeah, okay, I think let me stop sugarcoating it. This paper was, yeah, it was kind of rough, just a little bit, you know. Okay, not just a little bit, it was like towards the rough side, to be honest. Paper 1 was okay, but paper 2, Yeah, this one needed you to think, you know, needed you to think. Like here, you see thinking, some more thinking, some more thinking. It was quite an intricate kind of paper, but on the easier stuff like stats and I think stats, trigonometry. Yeah, the sections are definitely easy. Stats, trigonometry, and analytical. The wait, but that's like, what are you saying, bro? That's like most of the paper. Okay, I think it was 50-50. There was, I think, amongst everything, ne? Okay, the whole stats thing was easy. But then for analytical, I think it was 50-50. There's a portion that was hard, a portion that was easy. Euclidean also 50-50. Trigonometry, yeah, I think the trigonometry section was relatively fine for this paper. But anyways, if you spot any funny, if I wrote like plus or a minus where it should not be, just let me know. Just let me know and I'll fix up the memo. And obviously the PDF version of this memo, you can find it in the description. You can just click the link in the description and then you will be able to download it. Anyways, from my side, don't forget to like, subscribe, and share this with your friends. Anyways, yeah, I'm done. I'm so done. Let's just, let me go eat. Let me go eat. I don't know about you, but I'm gonna go eat some. And yeah, you will catch me in the next wherever you catch me. You know, there are tutorials everywhere, guys. On the course platform, you see, this is the course platform over here. If you've gotten this far, right, and you're not enrolled into anything on the course platform, yeah, that's just interesting. That's just very interesting. So this is, you know, the course platform, and then this is on Instagram, people. IG is Instagram, so feel free to DM me. And yeah, man, we will. You see, I don't even know I'm stalling. Like, this paper is done already, bro. Just go. Okay, let me go.